Ma'am, shall we start?
We can start. Okay, good afternoon, everyone. I, Dr. Pushpa, on behalf of Delhi Technical Campus, Greater Noida, welcome you all to the Day 3 FDP session on blockchain technology. I'm also delighted to welcome our speaker, Mr. Abhishek Bhattacharya. So now, without taking so much time, I would like to hand over to you, Mr. Abhishek Bhattacharya. Sir,
Thank
you
you.
may now start Day 3 session of FDP.
Yeah, thank you, ma'am. People are writing not audible and no audio and video. I is it can you, ma'am, confirm? Is it fine now? Am I audible
Yeah,
as well as visible?
yes, you are audible and as well as visible.
Great. And we are recording this, and we are also live on YouTube. All right, so we shall start. We have 140 people with us now. Great. So, ma'am, now I'm closing my chat, so I won't be able to take a look at chats because it
Okay.
really ruined the first day. So, anytime you have any question, please keep it for the end, and we'll take it up.
Okay.
Is it visible?
Yes.
All right, great. Welcome everyone. Good afternoon if you're in India, and thank you so much for joining us today. It is a Sunday afternoon. It was previously planned for Wednesday, Thursday, and Friday last week, but sadly we could not have make it happen because of some problems. We are very happy that even on a Sunday afternoon, 1:44 till now, of you have joined us. That's really awesome. Thank you so much for joining us. Yesterday, we received a lot of feedback that a lot of hands-on was pending. That is true. Believe me, when we are talking about blockchain as a technology, one technology that has been called as a pillar for the fourth industrial revolution by World Bank, it is not an easy technology. It is not a short form of any kind of technology which can be done within minutes, especially when we are talking about basics. Because basics is something that even I have faced, and everywhere I've taught that basics is what people face the most problems with. Once that is clear, once and that's right with any other topic as well, right? Any other subject, because once basics are out of the way, you know about basics clearly, you can really go ahead and deep dive into the technology yourself. But especially since blockchain as a technology, I found that the concepts are pretty different, very different. If you're comparing it with any centralized technology, it is very uncommon, and some concepts even seem like unrealistic to the ears. But and that is one of the core reasons why people face a lot of difficulty in getting started with blockchain. Going ahead in blockchain is not a problem, which is what I have faced personally, and I've seen in other people I've taught as well. With that in mind, but however, we have designed it. We heard your feedback yesterday. We have designed it in a way today that we are starting with hands-on, right? Now I guess some of you might not be able to catch up into on certain concepts when we are doing hands-on, because that's not how it was supposed to be done, because there's a lot of concepts to be covered. But I'll try and make sure that when I'm demonstrating a concept, I explain it. I also, oh, I forgot to hide my chat. So I also make sure that I explain those concepts so that you are at least can go hand in hand. And if you've attended day one and day two, then you are already on the very same page. Then we can get started. Even if not, then third day is not very related, because we are anyways diving hands on, and I'll be explaining the concept. So you're not going to be detached completely either. So with that in mind, let's start. Welcome. Thank you for joining us on day three. Today is the last day of the faculty development program on blockchain technology. However, we all of us are, I believe, lifelong learners, and with that in mind, every resource out there is out there in the open. I am out there in the open. Everyone else can just visit the dashboard, class dashboard that I've set up. If you're joining us for the first time, then there is a class dashboard. I've mentioned it on the chat. I'll again show it. Every piece of important information is present there, and that is where I'll be sharing any content I get ahead as well, even after this FDP finishes. All right, thank you so much for joining. Let's get started. All right, just an introduction for the new people. We'll just do it in 30 seconds. I am a co-founder of a blockchain startup. We are helping farmers get quick loans, and at the same time, we are helping banks save millions and millions in frauds every year in the sector of warehouse receipt finance. Apart from that, we are an IIM Ahmedabad startup, and personally, I've been into blockchains in the last 3.5 years, commercially, academically as well. Uh, Okay, with that in mind, before starting, I wanted to do something. I wanted to take a very quick poll. We saw that polls were very successful yesterday, and I got a lot of idea, especially about your profession and a lot of things, so that I could modulate the presentation in between. I am launching a poll. It will take 30 seconds, 1 minute for us to get all the responses, and I believe you'll reply to the poll. It's a very short poll. Please see if the poll comes on your screen. I request you to please start voting. No one has started voting yet. Yes, okay. I think people are able to see. Okay, that's a lot of people from outside as well. So this will take 30 seconds. We'll wait a minute, and we'll see what the results are. Maybe if there are some striking differences, then I will modulate it a bit. Great, half of you have already voted. Please, I request everyone who's getting the poll on their screens, please vote. We'll wait, 30 seconds are up. We'll wait for 30 seconds more, and we'll close the poll. By then, we should get a good idea of what's happening. I'm very uncertain. Why does the poll always go and get stuck at 60%? What happens to the others? Is it not reaching everyone, or is it that the other 40% are not on your computers or on your phones? Because poll is very, very easy to attend to, I believe. And in the between, if I'm inaudible or not visible, please write in the chat so that Dr. Pushpa ma'am can take a look, and she can alert me for the same. All right, we have received 102 responses. We have 10% from outside till now, 90% from India. That's great. As far as I know, we have people joining from Sofia, Bulgaria, France, Australia, the US, and I guess Germany as well, based on the registrations. Thanks a lot for joining us today. I'm ending the poll here, and great. Thank you for giving a heads up. All right, let's get started with today's session. Let's take a bird's eye view of what we are going to take a look at today. Today, don't worry if you have time. I will be having some time after 4:30 as well. So if you have a feeling that we are going slow, because it is quite possible. When I was covering theories, even when I was covering theory, I saw that a lot of people asked me to slow down. But on the other hand, a lot of other people said that already 40-50 minutes are up. When are we going to be done with theory? Now we are talking about practicals. If you want to follow along with me, if you want me to wait for you to open your Visual Studio or any code editor and do it along with me, this is going to take time, and we are thinking about a population of over 200, right? So even if we are delayed a bit, we'll try to cover as much as possible. Great. Let's take a look at the bird's eye view. All right, today we are going to be doing hands-on mostly, because that is the feedback I constantly received, even though I know that a lot of other people who are yet lacking on the basics, they'll face some difficulties maybe, but I'll just let me know in the chat, and I'll try to help you go hand in hand. With that in mind, so first thing that we are going to take a look at is the Bitcoin blockchain. We are going to look at the public Bitcoin blockchain. We're going to explore it. Yesterday we did the same thing with the Ethereum Explorer, with the Ethereum blockchain. Explored it in detail, pretty much detail, because we took a look at a very specific, a very famous transaction, and that transaction was from, I guess, 914 days back, and people also raised a lot of questions regarding that. Someone from Australia asked that if we are able to see the transaction between two different people from 3 years back, isn't it a privacy violation? It is not. I answered yesterday, just a line on it. Blockchains are public, but they are anonymous. You do not know who those two people are. That's it. Then we'll actually today build a blockchain. So you might be thinking that what it is. We'll take a look, and we'll build a blockchain ourselves here. I'll do it on my local, and via that we'll see how the hashing works, because yesterday I also got a feedback that the hashing process was not explained properly. And that is a very generous comment, because if this hashing process is not explained properly, I believe you will be having a lot of doubts in your entire blockchain learning, because this is not one of the, but this is the most important subject if you're learning blockchain technology, because everything is based on hashing, almost entirely. The security infrastructure, the algorithms, the working of the blockchain, everything, the consensus mechanisms, everything uses hashing as the underlying concept. So we'll take a look at a very live example, but we'll try to learn hashing via that example, because that is very important. And then at the end, we'll try to talk. Yesterday, we explored the public Ethereum blockchain, and today we will be using a library called Web3.js, and then we'll be using a cloud and a public online website that we have available, which allows us to connect to the main Ethereum network. With that, we'll be able to talk to the main Ethereum network. We won't be committing anything, because writing to the main Ethereum network is pricey. It's not pricey, but it consumes cost. I don't have that in my Ethereum wallet right now. I don't know if you just set up your wallets, you won't be having that either. In such a case, we usually use test nets, but we'll be talking to the main Ethereum blockchain, so we won't be committing anything, but we will be reading, and that is sufficient for getting you online to dig deeper even after this FTP. That would be sufficient, because we'll be exploring the libraries and the methods and everything. Right, so you can see today's bird's eye view. It is all hands-on. In between, we'll just switch to, after the Bitcoin blockchain, we'll switch to learning a bit about consensus mechanisms. Maybe it will make more sense. We were trying to do this yesterday, and some theory is required, because these are most important pieces of theory. All right, and please remember, you are learning 2020's #1 skill. Cloud and artificial intelligence are ranked #2 and #4. This is by LinkedIn. Blockchain is the #1 skill of the year, and definitely I'm very hopeful that it will be there for the years to follow, right? All right, before I start, everyone has been asking on chat feedback. Please give me a feedback if ever you feel anything. The link is there. I'll post the link on chat as well. Ma'am, if you can please post this link, feedback link, on chat. The dashboard link, as you can see here, it is the most important part of my course, any course that I do. And it is a completely public dashboard, and it is available on bit.ly/class dashboard. That's as easy as it is. And every piece of information, including about certificates, the recordings, PPT, any other materials, even today and after today, because again, we should be lifelong learners. Everything is going, there's a WhatsApp group, everything is there. It is very well arranged, but because we cannot get in touch anywhere else, please visit the classroom dashboard whenever possible, right? To get anything, any update. All right, great. All right, here we start. As I promised, the first thing that we'll be doing is a practical session, and so we are doing that right now. We will be exploring the public Bitcoin blockchain, right? So let's get started with that. Let me know. I'm switching my screen share, so let me know whenever you see the other screen where I'll be doing this. I haven't yet shared, so just 1 minute. Dr. Pushpa ma'am, can you please confirm that you are able to read the text today, unlike you were able to read yesterday?
Yes, I'm able to read it.
Great.
The block explorer, blocks, transaction,
yes.
average fee. Yeah, it's clear.
Yeah, it's clear, right? Because we'll be looking at code today. Now with that, the main problem is going to be that if you are not able to read, you won't be able to understand anything. And yesterday I found out it was because of the live streaming we were doing on Facebook. Facebook slows it down. So I'll start the sharing, and let me see how to share that. New share. Please let me know when you are seeing my Chrome.
Yes, it is visible.
All right, okay, I see the chat as well. Okay, someone has asked for feedback link. Not visible clearly. Yes, you can see clearly, right? Okay, and here's the feedback link. Great. All right, let's get started. So we'll just search for Bitcoin explorers, right? There are lots of Bitcoin explorers available in the market, so you can see all of these are Bitcoin explorers, because Bitcoin is a public blockchain. You have ample opportunities, ample options to take a look into the Bitcoin blockchain. There are of course popular ones like blockchain.com is very popular. BTC.com, as you can understand, BTC is the short code for Bitcoin. BTC.com is another popular explorer. Explorer.bitcoin.com is another popular explorer, and so we'll take a look at Blockchain Explorer. Please let me know if you anytime are not able to read on the screen or the screen goes away, because I'm using two screens. I might not even know that one screen is shared or not, and I'm continuing to work on that. So please let me know as soon as that happens, as soon as you believe that I'm on a different track. Now this is taking time, not in my hand. What's up? Ma'am, am I audible and visible as well, or is there an internet problem?
You are audible and visible also.
Okay, I'm facing an internet problem in the browser. I
You
don't
are
know.
facing, you are facing internet
Yeah, yeah.
problem.
That's very concerning, because you're able to hear and see me, but this is not opening. I don't know why. Let me try again. If it does not open in another minute, then we'll proceed with the PPT, and we'll try again in a couple of minutes. Google is not opening for me. I don't know what the problem is. Let's get started with the presentation, because we are anyways going to be lacking on time. If Google opens, I'll switch to the.
You start with PPT.
Yeah, yeah. I have Google open here. So if it actually opens, then I'll just switch to the practical session. Please don't complain, everyone, that again we started with theory, because we did not. I really tried my best to start with practical today, but since it's an online practical, so we have to have the connection, right? So let's take a look at. Let me see once. I don't know what's happening. All right, I've shared my presentation again. If this thing works, I'll let you know. All right, going ahead. Again, this was again this is again a practical session. Let's take it later. Let's take a look at some consensus mechanisms. We'll take a look at two consensus mechanisms from here: proof of work and proof of stake. We'll switch to practical again, and we'll try to do that. And else we'll just do one of the offline practical sessions. All right. With that in mind. Yesterday we discussed that the most important part in a blockchain system is to arrive at a consensus in a distributed network. Blockchain systems are distributed networks, and it becomes very important that all of the networks, all of the nodes in the network that are scattered across the entire globe, possibly, they arrive at a consensus regarding anything about that's happening in the blockchain, like the transactions that are being done, the blocks that are being mined, everything, right? To do that, there are lots of consensus mechanisms to us. The popular ones are proof of work, proof of stake, delegated proof of stake with DPoS, and then proof of elapsed. It's not very much used, but still, it's one of the popular ones. Most popular is definitely proof of work. That is because Bitcoin itself started with proof of work, a proof of work blockchain, and it was the first blockchain to come out in the market back in 2009. And so we'll take a look at proof of work first and what it is. Very short description. We'll keep theory very short today. So in proof of work, miners have to show that a particular work was done. They have to, by what I mean by this is that they have to perform a very complex calculations to ultimately arrive at the answer, the key, before which they can say that yes, I have done the work. So work is in literal meaning work here. I have done the work of solving this problem. This is the key. This is the answer to the solution. Please say that. Please accept my work as the correct work. And the first, I'm the first one to do that. And I should be getting the reward for the mind block. And then the particular block that he was taking care of, the particular block, and a block is just a block of transactions. There could be 10, 20, 200, 2000 transactions in it. And there's definitely a block size limit in every blockchain, but there could be multiple transactions in it. And when a miner creates a block and then finds the solution to this problem, then his block is considered to be mined, and that block gets added to the blockchain. That is how blockchains work. That is how proof of work particularly works. So this is a complex cryptographic problem. It's not complex to solve, as in it's not a problem where you have to do a lot of mathematical calculation. It is a problem where you just have one way of solving it, which is hit and try. You just hit and try, and for millions of times until you arrive at the key which gives the answer, because it is a hashing problem, right? We'll take a look at hashing. We took a look at hashing yesterday. And so in case of hashing, you can just hash one value and find the hash of that particular value, right? You cannot decrypt it back using we generally use algorithms such as SHA-1, SHA-256 and such algorithms. They are very secure algorithms. Even your banking systems, your Visa card, all of they use SHA-256, SHA-5112 kinds of algorithms. And once you hash a value using these algorithms, there's no going back. You cannot, if you have a hash of a value, you cannot decrypt and see that what the value was. That is the core of this problem that is that these miners are solving, because they have the solution in front of them, but they cannot go back, they cannot retrace back and find the value which gave that solution. So they have to hit and try, and then ultimately when they find a value which, when hashed using those algorithms, give the solution that has been given, that is when they say that yes, I was the first one to find this solution. And that is when the block is considered to be mined and added to the blockchain. So miners have to show that a particular work was done. It is not at all an energy optimized process. Proof of work takes humongous amounts of resources. People are not, especially in the case of Bitcoin, people are not able to mine Bitcoin blocks using their laptops or home computers anymore for years now. You need very specific hardware, ASIC hardware, application specific hardware, or gate array hardware, and all those kinds, which give you the which give you the capability and the capacity to perform such millions of numbers of calculations every second to arrive at that solution so quickly. But as you know, that when your systems are running at such high speed and such high amount of time, it is going to take a lot of time. It is going to take a lot of resources. Electricity, cooling is needed, and everything is needed. Plus server area is needed, because you cannot be doing it with one server. Usually mining pools are there which use multitudes of servers. So that is why it is not an optimized process. But it is strong to break amongst all. Why? Because we took a look at this concept. We will not revise it in detail. But when you are putting such an amount of work, it shows that this work went into securing this block. Someone to roll back that block, he needs to put more work in order to go back that block. It is not possible in cases of proof of work systems. Not possible a lot, especially in cases of Bitcoin and other and Ethereum. Ethereum is also proof of work based till now. And in these blockchains it is not possible, because there's a lot of work involved and used by Bitcoin and Ethereum. We'll take a look at proof of stake. In between, I'll just check whether my internet is back. I think my internet is back. I'll just try to open Bitcoin Explorer. If it does, we'll switch over to it. Yeah, my internet is back. As promised, I'm going to continue theory right now before doing some practical today. So I'm sharing that part of my screen. Please let me know once you see my okay. Please let me know if Google is visible to you all.
Yes, sir.
Great. All right. Let's start. Facing lots of network issues today. I see in chat if and people have commented yes. So uh, are you facing network issues in listening and hearing and seeing me, or can you please confirm, ma'am, if everything is fine? When I was telling about the theory, were you able to listen to me?
From my side, everything is fine. You are visible, you
Everything
are
is clear.
audible.
Okay, Sophia has given everything is clear. Thank you, Param sir. Thank you. Thanks a lot. All right. So we'll just start with uh, oh, it's Bitcoin Explorer. So that is the current rate of Bitcoin. As you can see, I by chance searched. That's 7.5 lakh Indian rupees, and that is as of today morning. I guess it is 9,600 US dollars. But we are not concerned with that. We were here. Let's hope it opens. One. All right, great. So I'm going to go slow because a lot of people might be having a slow connection where the screen will appear later. So if others are seeing it in a bit delay, please don't get irritated, because that's how we have to make sure that 200 people are on the same page. All right, so you are currently taking a look at the Bitcoin Explorer. Certainly, blockchain.com is a company which is providing not only Bitcoin Explorer, they started with the Bitcoin Explorer, but they are now also providing, as you can see, an Ethereum and a Bitcoin Cash Explorer as well. So yesterday we took a look at etherscan.io. Similarly, Ethereum Explorer, if you go here and take a look at the Ethereum Explorer, it is one and the same thing. It is a public blockchain, not proprietary to anyone. So if anyone is providing a different handle on viewing the blocks in any public blockchain, they are going to be showing you the same exact data wherever you go. We can, if you want, we can compare. You can go do it yourselves between Etherscan and this. It is always going to be the same data, right? All right, so what you're seeing right now is the latest blocks that have happened. You can see that just 4 minutes ago, someone who's unknown, the miner is unknown, just mined a block, and the latest block is 633540. That is the index of the latest block. Why is it called height? Because at any time the block height is the last block in a particular blockchain. That's what a block height is. The size in bytes is shown here. So what happened was that initially a block size was supposed to be 1 MB. Later on, a technological advancement came in Bitcoin, which called SegWit, for segregated witness, where you segregate the important information and only put that important information on the blockchain, and segregate every other data relating all the transactions in the block and handle it separately in other storage, and you connect them, and it's a deep technology, but that is what it means. It was done to make the Bitcoin blockchain scalable. Someone has asked what is height. As I just explained, it is the latest block in a blockchain. That's what height is. So you can see a very important concept. You can see a block was mined 4 minutes ago, another block was mined 6 minutes ago from now. So that means amongst these two blocks there was only a difference of 2 minutes. However, here there was a difference of 4 minutes. Again, here 6 minutes, 4 minutes, 7 minutes. You can see, and if you scroll down, there might be cases where you might see that there was a difference of maybe 40 minutes in creation of a block. The average time taken by a block by minus to miner block is averaged at around 10 minutes. That is what the important concept is, and that is particularly why still you cannot use Bitcoin and such currencies for maybe buying coffee at Starbucks, because you do not know when your transaction will go through. Bitcoin is currently facing, we can take a look. I mean, so Bitcoin is currently facing, if we see that if Bitcoin is currently facing a transaction throughput of around 4 seconds, 4 transactions per second. When we compare this with Visa, the Visa network you use every day, everyone uses across the world. Visa does on an average 150 million transactions a day. If you divide it by hours and seconds, it is 1700 transactions per second. When you compare that with Bitcoin's 4, 5, 7 transactions per second, it is nowhere near. I mean, it is very negligible, right? So that is why you can easily depend on Visa, but you cannot depend on Bitcoin yet. Ethereum is also 12, 13 or 14 transactions or 15 transactions per second. A bit better than this, but not really a huge advancement. let's take a look at, so these are the hashes of the blocks. Again, these are the hashes of the blocks, the hashes of all the transactions, right? This was the hash that was created when the block was being made and put into the Bitcoin blockchain. We'll take a look at a particular hash. Let's take a look at that. It's loading. I hope we are able to see. I don't know why internet problem is there so much today. Google is opening, so there could be a problem with the Explorer. So you can see in this another block got mined, which was 633541. Let's try to take a look at that now. Yeah, great. So this is a block. So we are currently taking a look at very important concepts right now in blockchain history, in Bitcoin, everywhere. And since most of you know more about Bitcoin, so I assume that this is of very interest to you. So these are, I hope the characters and everything is visible because they are very small on this monitor. Can you
Yes,
please
yes,
confirm?
yes, it is visible.
Yeah, miner is not anonymous. Roop Singh, miner is not anonymous because it depends. If the miner keeps itself anonymous, it's in their hand. That is why this particular miner is unknown. But if you go through the entire blockchain, entire explorer, you'll find a lot of blocks mined by Antpool, which is a pool. There would be Binance, which is one of the biggest cryptocurrency exchanges of the world. They also have a mining unit. So this is what they calculate. This is what they calculate because to arrive at this, they have to match this starting number of zeros. This is what the problem is. So please listen very carefully that what the problem actually is. Every miner who's trying to mine a block, they have to do one thing. They have to hit and try so that they are able to arrive at the hash, which also has a particular set number of zeros to begin with. This is how they know that yes, this is the right answer, right? So and this is told to them before. That is why I said that they have the solution. It's just that even though you have a solution to a mathematical problem, but you cannot trace it back. You have to hit and try and solve for it, and you have to find a solution, a value that when solved, when hashed, matches this hash. That is when you are able to take it as the correct answer. So confirmations is one. Why this is another. So we'll just take a look at this quickly because we have lots to cover today. So this is confirmations is one. What is confirmations? Confirmations is how many blocks have been made after this particular transaction that you're seeing. So we are taking a look at one block. Any transaction which is a part of this block, if we go to that transaction, we'll also see that they also have confirmations as one. In Bitcoin blockchain standard across the world, the community has taken that that we generally consider 6 confirmations as a good sign that one transaction has been completely committed to the blockchain. So and what confirmations means is that how many blocks after this particular transaction or this particular block have happened, right? So this is one, as we just saw that this was the latest block, right? If you go to any just the previous block, you'll see that the confirmations is 2, right? We'll try to see the Genesis block today, which Satoshi Nakamoto, the creator of Bitcoin, did. If net works, if I can search Google properly, I'll show that to you as well. And that possibly will be having a very good match here would be that Satoshi's first block of Genesis block. The first block is called the Genesis block in a blockchain, any blockchain. So that will have confirmations equal to the height of the Bitcoin blockchain right now. Why? Because the height is the latest number of block that was done. And if you're at the first block, the confirmations would be all the blocks after that. So it would be height -1, right? So let's take a look. Number of transactions 981. This can vary a lot. This could be 20 transactions in a block. It could be 20 to 100 transactions in a block. So these are the number of transactions this particular miner pulled. Based on anything, it could be based on just random selection, or it could be mostly it is based on the transaction fee that is attached with every transaction. So you'll see it here. So they picked 981 transactions and created a block out of it, right? Simple. Difficulty is the measure. Please listen carefully. Difficulty is the measure in any blockchain, proof of work blockchain especially, which defines how much work would it take for a miner to actually arrive at that solution. So there's a lot of maths involved in difficulty. You have to be below a target level when you are able to calculate that hash which has that set number of zeros. So for example, if the blockchain protocol says that in your hash there has to be 1 0. So so that is 1 0, the probability would be something, right? If that is 2 zeros, the probability would be half of that, right? So this is how it increases. So first if we just have to get the first character as 0 in the hash, it would be 50% probability that it will either be 0 or not, right? If we have to get the first two characters as 0, then it would be 25% probability that it would be 0 or 1 or not, and then it would be divided by the 2 to the respective power of 2, right? So that's essentially what difficulty means. A very important concept next is this Merkle root. We took a look at Merkle root in detail yesterday, but still I received feedback that the hashing was not explained properly. So please take care of this concept. Merkle root is very, very important. Merkle root is what gives security to the blockchain. This is the sign that everything is fine with this block, right? How? What is Merkle root? Yesterday we had a very good illustration as well. If you have been here yesterday, I'll just repeat it once because I've received a couple of feedback. So Merkle root says that what Merkle root is that consider a block of transactions, right? So if there are 6 transactions, you take two transactions, pair of 2 transactions, right? They will be the leaves. You combine them and you create a hash, a combined hash. So first of all, you have a hash of the first transaction, hash of the second transaction, right? Second, you will combine both the transactions and create a new hash 1 2 of transaction 1 and 2. Then again, on the other hand, on the right side of the tree, there would be again transaction 3 and 4 whose you have already created a hash. You will combine both these hash 1 2 and hash 3 4 and make another hash, right? When this will end and we'll only be having one node at the bottom, if you consider it as a Merkle tree, there would be one parent node remaining, right? When you reach that, the hash that you find, because you have hashed every individual transaction, every individual pairs of transactions, everything has been hashed and hashed and hashed. So when you reach the parent node, that is the hash. This is the hash. That is the hash we're talking about. This hash is the combination of all the hashes in the network. Now, if you change anything, in any of the transactions, this changes completely. How we will see it practically today. Everything is practical today. Just bear with me for some time so that you get the concepts. And this is also, we are doing practical as well. This is hands-on. You're taking a look at the very public Bitcoin blockchain. Everything is in the open. You will not find a technology. Name me a technology which uses, name me a company which uses Oracle databases or MongoDB databases, and you have their data such in the open. There isn't any. Next is the version is irrelevant. It is the current version of the client, I believe, and bits is the size. These two became different, size in bytes and in bits after SegWit came, because there have been consideration of different calculations of sizes. I mean, before, if it's a non-SegWit block, I don't remember the calculation exactly. If it's a non-SegWit block, the calculation is 1:1, I think, 1 bit per byte. If it is a SegWit block, I think it's 4 bits per byte, something like that. So just to make it more scalable, it does not mean that they don't take the same space on the disk, physical disk. Obviously, everything in computer science takes space as per the bytes that we know from our childhoods. But this is just to tell the protocol of what size to consider that as, and this is just for matters of scalability. Nonce, a very important concept. This nonce is what you add to your calculation to find this very hash of the block. The nonce is the trial that you do, the hit and try that you do it with this nonce. You repetitively, because you have the solution, right? You repetitively attach, combine, because you have all the other data. See, hash is nothing but the hash of a block is nothing but another hash of all the respective data that a particular block contains. It could be the timestamp, it is the transaction values, it is the previous block's hash, which is the important part, and a very important part, that is how the blocks are linked. And at the end, these all are hashed together. With that, one unknown variable, one unknown value has to be attached, concatenated, and then hashed repetitively, and to find this hash. That value is nonce. when you are able to find the perfect value, and I hope all of you are faculties, as I saw 80-85% of your faculties here, you know more about cryptography, much more than me, so you'll understand it here clearly that because hashes are constantly changing, and even a single change in any value creates a humongous change in the resultant hash. So you just start changing this hit and try, and then you start changing the nonce. When you find a particular nonce, which when concatenated with the other data of the blocks of the transactions gives you this unhashed, gives you this hash that you want to see with maybe 19 or 20 zeros at the beginning, which is defined by difficulty. All of these are interlinked. Try to try to grasp it as we go. You can read more about it later. So these are all interlinked concepts and very mathematical in nature. We can't even go into the mathematics of it, but beautiful. These all are very beautiful concepts. And believe me, if it wouldn't have been so difficult, our systems would not have been strong, and our systems would not have been such secure. That is, blockchain is unlike any other RDBMS or NoSQL or any other database management system or ledger technology or any kind you have seen till now. It is a combination of a very secure database as well as a ledger, right? And it's public, it's secure, it's public, but it's anonymous. It's anonymous, but it's transparent. It's a beautiful piece of technology, no doubt. It's taking such mainstream attention now. So that is what a nonce is. You have to find this nonce, and once you find this nonce, you declare it to the network that I have found the nonce. And this is how you tell the network that I am the miner who has found the nonce, because you give the nonce. Now, okay, so even if you're feeling bored, please listen to this last line. Anyways, we are doing practical. You're seeing the blockchain directly. This is the blockchain, right? What else is blockchain? This is the representation of blockchain. So when someone finds a nonce, so entire concept of proof of work or hashing or mining is based on the fact that finding the solution is very difficult. But once you found the solution, checking it, comparing it, checking if the solution is correct or not is very, very easy, because finding the nonce that hashes to give you the final hash is very difficult process. But once you have the nonce, if someone has this nonce and wants to check it against, once you have this nonce 2115305119, you attach it, you concatenate it with the other data of this block, 1 second, and you'll get the data, and you'll get this hash. That way, all other nodes can use this nonce and hash the block and check that whether it matches the hash which has been displayed to the network. If it does not, then everyone knows that you cheated. The nonce that you have, the ones that you have broadcasted to the network, the nonce, it is incorrect. That means you have cheated. This is how people know, because the work that goes in finding the hash is not equal to the work that goes in just checking whether you are saying the truth or not. All right, we are losing time. Let's go ahead. Important concept: transaction volume. All those 981 transactions amounted to a transaction volume of 1790 bitcoins. That's a huge number, but that's anyways a block, entire block we are talking about. The block reward is what people get, the miners get on because they have spent all their resources in mining the block, right? This is what they get in return. Until May 12, just May 12, this May 12 I'm talking about, this reward, block reward, was 12.5 bitcoins. On May 12, Bitcoin halving happened, third Bitcoin halving, and it halved the block to 6.25. Maybe 3-4 years later, it will again be halved, right? This is the block reward, and this is the fees reward. Fees reward is the accumulation of all the transaction fees that are associated with all the 981 transactions. The miner gets all of this transaction fee, but it goes out of your pocket. It goes out of the pocket of the person who is doing the transaction. So hence the miners earn is this plus this. Great. So let's take a look at the transactions in this block. This is why this is shown as a first transaction. It is called a coin-based transaction. A coin-based transaction in a blockchain is the transaction in which the coins are newly minted and transferred to the miner. So this is the miner's wallet. This is the miner's wallet. A coin-based transaction will always happen from the network to the from nowhere. It is from nowhere because it is generated by the network. So it is just sent. The transaction is just sent to the receiving wallet of the miner. That's it. That's how it happens. That's how the protocol works. And that is why it is 6.34, because it is 6.25 bitcoins plus 0.09 bitcoins, right? It's clearly visible. Everything is out in the open till the last decimal point. Nothing goes out of sight, out of mind here. Going ahead, these are some transaction. This is one transaction. These are individual transactions. These are hashes of those individual transactions. That is what I said when calculating the Merkle tree. Two transactions like this transaction could be combined to create a hash. Again, this transaction could be created to combine to create another hash. Then the hash of both these and the hash of the earlier two transactions will be combined to create another hash, unless you are left with the Merkle root. I think it should be really clear by now because you're able to see it directly. These are all the, so see, these are all the transactions. These are the unspent transactions from where it goes to the different wallets. These are the two from wallets. These are the two wallets. Everything is there out in the open. I don't think there's anything more to be shown. We can change the network from here. And let's go into a transaction and see that if there's, let's go into a Coinbase transaction and see if there's anything new that you can see. All right, if you go inside a transaction, we were inside a block, now you're inside a particular transaction, and this happens to be the Coinbase. As we go in, we are seeing again the same things, size, weight, included in block. As we just saw, we were taking a look at 633541 block. Confirmations 4 means by the time we were talking and we were showing 4 more blocks, 3 more blocks happened because one had already happened. So even if you could just go back, the entire block will show a confirmation of 4 at the moment. Total input into this particular transaction was 0 bitcoins because, as I said, Coinbase transactions come out of thin air. That's exactly what the protocol does. It just mints new coins. So there's only a output, there's no input particularly to it. There's no fees because it's a Coinbase transaction. Everything else is empty. But this 6.2 bitcoins currently, 6.25 bitcoins currently are valued at $61,000 because one is at $9,700 as of now. Let's go back quickly. I hope internet is working. Yeah, let's take another transaction which is not a Coinbase transaction. You'll see an input value is there. These are confirmed. Also has a confirmation of 4. Date and all is there. Fees is there. Total input is there. Total output is there. This means that the wallet used the entire input and spent it to another wallet. The fees is there. This goes to the miner, and value when transacted was $3,286, which matches because 0.34, that's 30% of a Bitcoin. If it's $9,700, then the value is very correct, right? All right, let's go back and let's quickly see. I think that's sufficient to be shown in the. All right, I told you that I'll try to search Google for taking a look at the Genesis block of the Bitcoin blockchain that Satoshi Nakamoto did 11 years back. Dr. Pushpa ma'am, can you please, I'm seeing you're unmuted. Can you please confirm if everything is all right? You're able to hear,
everything
everything
everything is all right. Everything's all right. What I'm suggested, can you take 1-2 questions from the chat box, like Mr. Roop Singh, like Mr. Roop Singh is asking how transaction fee is decided. Could you take
transaction fee is not, yeah, right ma'am. Okay, I'm checking the chat now. I'll take a couple of questions and then we'll move ahead because
we just have 2-3 questions right now.
Then go ahead. We'll take 2 questions because on the first day we saw that it was a chaos. So how the transaction fee is decided? Transaction fee is not decided. There's a maximum limit to sometimes people keep on a transaction fee. The minimum limit people keep to a transaction fee, below which you can keep it with that, but it will never be picked because that's unrealistic. Becomes unincentivized for the miner to pick it up. Apart from that, there's no decision on the transaction fee. It is completely in your hands. You can set if you're transferring 1 bitcoins, you can keep your maybe a couple of dollars in bitcoins as the transaction fee. If it is like if it looks attractive to any miner, they'll pick up your transaction because mostly when yesterday we discussed the concept of mempool, mostly when you have a host of range of transactions in the mempool, usually miners what they do is they just sort it with the transaction fee from in a decreasing order, and then they pick the most attractive transactions from there. So the more the transaction fee you put, there's a much higher chance that your transaction will be picked and processed and put into the blockchain faster. But you are free to give any amount to the miner as you want, just to make it more incentivized. Because yesterday I discussed some anecdotes where people used for 1 bitcoin, someone used 30 bitcoins as transaction fee. That went away. Blockchain, another concept, blockchain is immutable. Once you do something on the blockchain, you cannot take it back. It is not, there is no undo, there is no control Z. right? So, and there is no cancel transactions. Maybe in Paytm you might be able to do, be able to call Paytm and tell that I have done this a lakh rupees via Paytm wallet by mistake, please do something about it. Paytm might be doing. And also, you know, the other person, you might directly go to his house if that is the case. In the case of blockchain, you can't do that. Once it's gone, you don't know who has received it from you. You don't know, there's no central authority you can just dial and talk to. It's out of your hands. Especially in the case of transaction fee, it does not even reach to the other person. It reaches to the miner. The miner is free to do anything with that. If they're kind enough, they'll return it to you. So yeah, so that is how you decide the transaction fee. So the fee is newly generated Bitcoin, which means no one pays. No, Miss Matilda, no, that is not the truth, because as you saw, fee reward is different, block reward is different. Block reward comes from the protocol. The protocol mints new coins. And why is Bitcoin so valued at the moment? Because it has a very limited quantity. There are only going to be, if I'm not wrong, there are only going to be, let's search it, there are only going to be 21 million Bitcoins ever in the world. Bitcoin supply limit, let's see. Yeah, the limit is of 21 million Bitcoins, and once that is reached, no new Bitcoins will be generated. That means miners, I don't know what is going to happen at that time, because the miners will lose the incentive, because there will be no block reward, because block reward is all about, and it is the only way how new Bitcoins are minted from the protocol, right? So that's the limit. And with every, you can see that with every transaction, with every block, 6.5 Bitcoins are 6.25 Bitcoins are being generated. Until May 12, it was 12.5 Bitcoins. Before that, it was 25 Bitcoins, and initially it was 50 Bitcoins when Satoshi started it. For 4 or 5 years, it was 50 Bitcoins. So you can see that every time this is being generated, it is decreasing from 21 million limit. That is why people know that this is a scarce resource. Simple economics. With such a scarce resource, the supply is very less, the demand is supremely more. It has now, since the Bitcoin and blockchain and all have come into great demand, mainstream adoption, yet it is not mainstream adopted, but still the demand is so high, supply is so limited. That is why that's the reason why a one Bitcoin is valued at $9,700. That's huge. 7.5 lakh INR. And December 2017, this thing was valued at $18,000, 1920 lakh INR. That this is humongous, and that is why. So yeah, definitely people pay. Block reward is paid by the Bitcoin, the protocol. The fee rewards are paid by the transactions done by the people who are committing the transactions. How is Bitcoin valued and why is it so volatile? I just answered that. Why is it so volatile? Because, to be very honest, it does not have a very for example, for once the US dollar was, maybe, I guess, backed by gold, right? A physical entity like gold. In the case of Bitcoin, it is a currency which has no backing of any physical material. So so for example, if you are backing something with a physical material, you know that it is kept stored somewhere, and the value is pegged 1:1. In the case of Bitcoin, there is nothing as such. So it is all about speculation. That is why people use cryptocurrency exchange. I can just open one of the exchanges. Let's make it very practical today. Everything you're saying, let me show it. I'm opening one of the biggest exchanges today. I hope my account is not logged in right now. It isn't. So I'm opening one of the world's biggest cryptocurrency exchange, based out of China. And currently you can see that this is how Bitcoin has been. This is how Bitcoin is volatile. Just take a look. And these are all coins. So Bitcoin is one, and hello, yes.
Can you share the URL?
It's just Binance.com. You can just search for Binance. I'll just paste it, but it is a very popular cryptocurrency exchange. I'm pasting it.
Okay, you just paste it.
Yeah, I'm pasting it. And Binance.com is a cryptocurrency. Disclaimer: this FTP, this session has nothing to do with financial suggestions. Saurabh Jain, I think, was asking for. Oh, Saurabh, yeah, that is what I thought, that you might not be asking for Binance.com. You might be asking for the Explorer. So it was blockchain.com/BTC. That's where you find. In fact, this entirely, I'll paste it here. This is the hash. This is the block for the current block, and you can just play around. You can just visit blockchain.com, see the Ethereum network as well, Ethereum Explorer as well. And just to give you a couple of minutes of show what a cryptocurrency exchange looks like, these things are still very silent now. December 2017, 2018 beginning, these were just flooding the market. Bitcoin was valued at a whopping 18 17 $18,000, 15 $16,000. Then transactions were humongous, market strength was a lot. These things were like you can see all these transactions happening in real time. All right. I will not answer that actually, Ms. Roop Singh. I will not answer that because there are a lot of places on the internet to check. Even though Supreme Court has allowed banks to provide you services for Bitcoin for buying cryptocurrencies, but since May 4th, but please do it at your own risk. And that was the disclaimer I was giving. This FTP has nothing to do with cryptocurrency, Bitcoin value, Bitcoin buying, Bitcoin investing, crypto investing, has nothing to do with any of these. Just because it came into the question, I opened the cryptocurrency exchange to give you a glimpse of what is there once you get into this sector. But it is completely different. What you're seeing right now is an implementation of blockchain. The technology is, underlying technology is different, and you can do anything with it. It does not have to be cryptocurrency, right? All right, so that's it. That's mostly it. We'll close it. This is not the topic of our, this is not in our these just one pointer. When you see these are all pairs that are available to buy. And any other coin which is not Bitcoin is called altcoin, just for alternate coins. That's it. One concept you'll read when you'll see that this is the volatility that you see in even the share market in India or any other place. You won't see this kind of volatility, right? If for example a share of Idea is going for a run of maybe 19%, as it happened just yesterday, from maybe 9.25 rupees to 10.5 rupees, that's a big jump. 10%, you close down the markets. These markets don't get closed. Also, when, as we know that our Indian share market or any other share market run for a set period of time during the day, 6-7 hours, and after that they just shut down, and then again open the next day and are closed on holidays. Cryptocurrency markets are not closed on holidays. In our share markets, when it reaches a particular when the volatility is above a particular limit, so for example 10% is the first bar which has been set by markets such as NSE and all. When it hits 10%, the trading stops. Here, any one day any currency can even increase by 100%. Trading will not stop. One reason is that these are not that regulated, and then also, which is a reason why people lose tremendous amount of money in cryptocurrencies, because either people are trying out cryptocurrency trading when they are unaware of every detail of this. It has taken me 3 years to get into cryptocurrency trading properly. It takes time. Unless you know everything, you are going to lose money. And also because people set up some buy sell pairs, then they forget about it. It sometimes jumps 100% more, 100% less. You lose your entire money. That's it. That's where we'll close. Just a word of caution: please be very cautious when you are doing anything in cryptocurrency, and always refer to the laws you are of the country you are in. It can drastically change. Until some time back, it was very, very problematic to deal with in India. Right? We'll close it here. Sort of what is difficulty and who decides this difficulty level? Good question. I touched difficulty a bit. It is a mathematical concept, and who decides this difficulty level? It is difficult. It is decided by the protocol. The protocol makes sure that the difficulty level is such that every miner, on an average, takes 10 minutes to mine a block. That is why the average mining time for Bitcoin blocks is 10 minutes. So it could go sometimes higher, sometimes lower, but and that is why the protocol constantly okay, Shweta, twice I gave question. Okay, let me take a look at your question once. So what happens is that so whenever the protocol sees that the difficulty is going haywire, and maybe you're taking 40 minutes to mine a block, it changes, and it then changes the difficulty, so that it again maintains that level. It usually happens in around 2 weeks after 2016 blocks, more or less. The difficulty is adjusted. So difficulty is regularly adjusted. Okay, twice your question, Miss Shweta. I am not able to see your question. Hash is of current block or previous block. Is it your question, Miss Shweta? Can you write hash? Here is the hash current block or previous block. Not this one, previous one. No, okay. Mishweta, please can you let me, if you're asking about the hash, then the hash you're seeing here is the hash of the current block, but this contains the hash, that is the important part I was saying. This yes, Bitcoin block, great. So this hash contains the hash of the previous block. That is how these are related. Yesterday I was teaching hashing, and that is what I said. I'll try to just show you in code today. If we have time, we'll try to make out time. This hash contains the hash of the previous block, that contains the hash of the previous block, hence this also contains the hash of any of the previous blocks, right? So that is why if even if I go change something, very important concept, unlike anything you have heard in your centralized world, if I go and change even a digit in what Satoshi Nakamoto gave to Hal Finney in 2009, 11 years back, that will result in the hash of this block changing, because every hash of this block contains the hash of the previous block, which has the hash of the last block, and so on. All of it is a hash, but because hash functions work in a manner, I have a slide on that. Hash functions work in a manner where whatever value you're hashing, however long the value is, the resulting hash is always of that particular size, which in this case I'm sure it is 32 bits or 32 bytes. So that is all it is going to be. So whatever data you want to put in, but it is always going to be the same size. But anything you change in the data in somewhere, it is going to result in a completely different hash. It does not mean that only one character will change here. I'll try to show it today in code, right? Okay, Saurabh, I've already taken 5-6 questions. This always delays it, but we'll definitely take all questions later. All right, I think we saw all of this. We saw blocks, and yeah, I was at a very important position. I wanted to show you the first block. So I said that I'll search on Google, but I don't think you need to do that, because this is the block hash. I think if I put one here, let's see. If it does not work, we'll try to find the actual hash from the. Okay, it did. Great, it did. So it clearly seems that this explorer is after this slash block. It is also taking the block's hash, and it is also taking the block number. Again, that is a very useful way it is handling routes, because if you're a developer, you'll understand that when you're handling routes, you are expecting a particular kind of data there. So if you're handling this, it is very wonderful. We are looking at the very first block that happened on 9/1/2009. As I was saying, that it happened 11 years back in 2009 when Satoshi did the first transaction. This is not the first transaction between Satoshi and Hal Finney. This was the Genesis block. The block is Genesis block. The transaction did not happen here. But what happened is that the Genesis block was put in, the mining happened, the block reward went to the miner, and the newly generated coins were minted out of thin air by the protocol and then put into the miner's wallet. So we are taking a look at the very first block that Satoshi Nakamoto himself did. Okay, please remember a very important concept. Any blockchain you're creating, even though the blockchain is very decentralized and very autonomous, but you have to generate the first block, without which it becomes very it does not go ahead. So what happens is that the first block does not have a previous hash, right? Every block has to have a previous hash. So for the first block's case, you have to manually give a hash. I'll try to take a look at it using code. So this is the first block we are taking a look at. Dr. Pushpa ma'am, just confirm if everything is visible. Everything you are able to see the first.
Yes.
Great. So also guys, if I'm going fast, if I'm speaking fast, which has been a constant feedback forever for me, just let me know. Just let know in the chat so that Pushpa ma'am can tell me. All right, we are taking a look at the first block. The height is 1 because that was the latest block at that time. It was the first block. Miner unknown, number of transactions 1 because Satoshi did not do any transactions here. So the only transaction that the block had was the Coinbase transaction. Difficulty was nothing. It was 1, and that's it. That's all it was, because it started. Merkle root was given. Size is given. Nonce is given. Transaction volume is 0 because no transaction was done. However, the block reward, yes, this is what I was talking about. It started with $50 Bitcoins as a block reward in the beginning. Now it has halved and halved and halved for the third time, and it has come down to 6.25 Bitcoins. if you're taking a look at a bit, if you just go on the Explorer and take a look at a block from 30 days back, before any, even 12th May, you will be seeing that the same, this position, block reward, it will be showing 12 and a half Bitcoins. That is the beauty. Everything is open, out in the open, right? Transferred on 9th, on in 2009, and great. So I think so. All right, yes, we are done on this part. If there is anything to show,
Hello.
yeah, yes, ma'am.
I think you're not changing your screen.
No, I'm not changing the screen yet. Yes, ma'am. Yeah, you're able to see the Explorer yet, right?
Yeah, okay. Okay.
Yeah. So I just telling you something that here you have a bird's eye view of what's happening. If you click on blocks, you'll see the latest blocks. So see, Antpool has mined, BTC.com has mined, BTC.com also gives you a blockchain explorer. We just saw. All of these are miners, and these are the times when it happened. These are the hashes of the block, and this is the height. Okay, let's take a look. A very again cross-referencing a very important concept. We just took a look at height, right? It is 633547. Which means that if I visit the first block, Satoshi's first block again, the Genesis block of the Bitcoin network, it will show it will show confirmations as this or this minus one, right? So, what was it? Yeah. Yes, this is what it shows, because it was the first block. And after that, 633547 blocks more blocks have been confirmed till now, till date, till this very second. It is real time. Blockchain networks cannot be slow. They are not killable yet, but they are not slow. They have to be reflecting at the same time everywhere. So this is the number of blocks that are formed, and that is what we were seeing here. That is the number of confirmations. That is why every new block forms adds into the confirmation. People in Bitcoin wait for at least 6 confirmations. So that is why people in this transaction, people doing the transactions in this block, in any of these transactions you're seeing in this block, they are having confirmation of 1, because hardly any block has been done after that. So people will not accept these. So if you're saying that your friend, I have transferred you 5 Bitcoins, and if that has just been processed and it is in this block, your friend will be saying that I am not sending you the goods, or I'm not sending you what I'm supposed to do for you until at the moment, because anything can happen now. Unless what your friend will wait for is, so something like this, when you at least have
hello, Abhishek.
Yes, ma'am.
Can you just tell me which block? I mean, I'm just. I think your screen is not moving. Can I read
I'm currently on 633536.
No. What I can read, block 633541.
Is it?
Oh, yes.
Okay.
This is what we are asking. Number of transaction 981. Like this.
I'm not able to see first block. It is still 633541. Okay, that is.
That's the problem.
Yeah, make sure the changing screen is not the problem. Actually, the internet could be a problem, because. Okay. Changing screen could be a problem. I don't know. Just let me know if this changes. Okay, just let me know if this changes. Currently, you're seeing 633541, where the confirmations are 4, right? So if I go to, no, so what we wanted to do is we wanted to go to the first block, right? Let me know if you see the first block now.
Yeah, block 1.
Oh, thank God. Great. Okay. Yes. Okay. All right. So Mr. Ankur Agarwal has been kind enough to ask to inform. Thank you, Ankur. I'm very sorry that screens changed. Technical problems. You can be a developer but still face these technical problems. It's very common. So you are taking a look at block 1. All right, I was explaining this concept that we are currently seeing 633547 as the confirmations for the Genesis block that Satoshi did at the beginning, and this is back 11 years back. This is how we can confirm that confirmations is the number of blocks that have happened after that particular block, right? So how can we check this? The confirmations for Genesis is 633547. We go to blockchain.com We go to BTC. I think it should open the Explorer for us. No, it gave an error. Let's see. Yeah. All right. So here we can see that after that the latest block right now is 633548. This exactly matches to the confirmations shown in the case of Genesis block. 633548. That's it. The height and the confirmations are related. That's how they are related, right? So I hope you've been able to see that. All right. So Ankur, if you have not, if you guys have not seen 10 minutes, last 10 minutes, I'll try to repeat the most important concept out of that. So and Pushpa ma'am, if anything like this happens, just let me know immediately. So last, that is what I actually helped you understand at the end, that a couple of concepts, not very important, it had to be shown, but it took time because I was explaining. So if you've heard it, then mostly you've got it. So what I was saying is that the first block had this only Genesis, the Genesis block, which is the first block, had this one transaction, which was just the Coinbase transaction where the network generated 50 bitcoins and gave it to the miner, right? It started from 50 bitcoins, which is, I was saying that if you now see, it is 6.25 bitcoins, started with 50 bitcoins. First halving happened after around 4 years to 25, then to 12 and a half, and on May 12, 2020, it became 6.25. You pick up any block from before, let's not spend time on that. You pick up any block from before 12 May, you'll see that the same block reward there is 25, is 12.5 bitcoins. Someone has raised a hand, so is there a question? Okay, so if there's no problem, ma'am, I'm not seeing the chat anymore, then I'm continuing. All right. Just 1 second on Ethereum. That yesterday we were using etherscan.io to check this. You can check it here as well. This is the Ethereum Explorer. Though, yeah, the Bitcoin, the Ethereum, and the Bitcoin Cash Explorers are all here. This is the block height of the Ethereum blockchain, and these are the hashes, and works in the same way. It's proof of work, right? And is there anything else I wanted to show? Bitcoin, I was showing when you said that you are not able to see the screen, I was showing that you get a bird's eye view. You can click on transactions. You can see the latest. These are the latest unconfirmed transactions. This, you are taking a look at the mempool, the concept which I explained yesterday. This is the mempool. People, the miners, pick up transactions from here. How will they do that? They'll see this. They'll associate. They'll see the associated transaction fee, order it, and maybe pick up the most recent 500 transactions at random. So no, I think I've said something incorrectly. This is the unconfirmed transactions, means they have gone into a block, but they have not been put onto the blockchain. However, the mempool that I explained, which is this is the mempool where the transactions are there, which have not yet been picked. Yesterday, when I was showing you a concept of CryptoKitties, which bombed the Ethereum network. At that time, the main problem happened was that there were a lot of pending transactions in the network. That means people were not able to process transactions. So at that time, if you take a look at the Ethereum network, this graph will be humongous. This graph will be very high, right? Great. So this is what mempool is. The mempool is, this is hash rate, the rate at which you are the network is processing the transactions. This is the difficulty, as we again discussed. This you can see it is going up and down. It constantly gets adjusted after every 2016 blocks. That's the price of the Bitcoin. This is transactions per day. Okay, so sometimes the Bitcoin network is not very used for transactions. Sometimes it's highly used, right? This is the last 24 period network. If you divide this by the number of hours and then the number of seconds, you'll get around 4 transactions per second. You can do that at your leisure, and that is how you can compare that Bitcoin is lagging a lot with VisaNet and all, right? Okay, all right. So I think that's where we end Bitcoin Explorer. Yeah. All right. Let's switch back to our presentation and let me know, ma'am, please, when the presentation is visible. I'm facing a lot of technical problems today. Prayas, will smart contracts be taught? it was in my schedule, Prayas, but the way we have went through the last 2 days, the speed at which I have to maintain, even after that I was given feedback that I was going very fast. I could not cover smart contracts. I just removed the slide from the smart contracts. I'll give you an overview. Coding smart contract will not be possible. If there's a lot of requirement for that, please let us know anywhere in the mail, in the on the dashboard, in the WhatsApp group, anywhere, and I'll make sure that I can do a video, the similar video, and upload it on the dashboard. That is the max I can do. Otherwise, everyone here will have to sit till at least for the next 2.5, 3 hours to cover all those topics I want to cover. Um, all right. So, ma'am, are you able to see my presentation? Hello. Now, someone has to confirm whether you are able to see my presentation or not, because can someone write in the chat, please? Am I lost? Okay, thank you, thanks a lot, thanks a lot. I just thought that I'm totally off. I'm sitting in. Uh, Great, thanks a lot. Yes, we can. Okay, great. So I'll just yeah. Thanks, Sophia, Kriti. Thanks a lot. Yeah, I'll just proceed. Uh, yeah, thank you, Madhuri ma'am. Thanks a lot. Thanks a lot for attending. So we have people from all the industries. We have all people from all sectors: civil engineering, mechanical engineering, from outside India, joining us here. Today I'll make sure that I explain the concept so that they are not very specific to computer science and IT engineers only. Right? These are the basics. Still the basics. Right? You can just move around in the network online anytime you open your browser, and you can move around in the public Bitcoin network. Not something you can do with any centralized network. All right, let's go ahead. We'll quickly cover theories, because today even I'm not in a mood to cover a lot of theory, unlike the last 2 days. So proof of stake is a different consensus mechanism, which is much more energy efficient, because you do not have to put up a lot of hardware resources and network resources and electrical resources to calculate the hash. What you have to do is you have to stake your part of the currency, native currency of the blockchain that you have. What you do is you stake it, and for the longer you stake it, the more the value your stake, the more value your vote has if your stake has been longer. So what miners have to do, that is what miners do. The block creator, who creates the block. In this case, you saw the first one to do the transaction was the block creator. In this case, the block creator is decided using a random combination of age. Age means for the time since when you have staked your coins. Staking your coins means that during that time, you cannot use any part of that coin. So if you have 1,000 rupees and you're staking it, you cannot use that money. It's similar to share market. If you're buying something that that part is blocked, you cannot use it, right? So it is there in your wallet. The ether also will be in your wallet, but you won't be able to use that ether if you're staking it, unless you remove it from staking. So the longer you stake, the more value your vote will have, and also the amount of currency that you have is very important. So it's not like you just have one ether and you're staking it for the last 10 years and you are the most valuable. Of course not. And that is why sometimes it becomes one demerit becomes is that whales have a lot of say, because whales are the people who have a lot of a particular type of currency, so they can easily stake a huge amount. They can stake it for longer durations. So if a huge whale stakes it, he'll have a higher say. And if that overpowers everyone at that time, it might become centralized. Nothing that any of our popular networks have to worry about now. Theoretical concept is that whales can overpower, and hence the system will be less decentralized and more centralized. Much more energy efficient, as you could see. Resources were not being used. It is faster as well. We'll quickly take a look at delegated proof of stake. Yeah, we'll quickly take a look at delegated proof of stake. It is an innovation on proof of stake. What happens is that you here also you stake your coins. What happens is that this DPoS has a staggering speed compared to any other consensus mechanism like POW or POS. Right, and block creation is staggeringly high speed. The transaction throughput is very high, but it does not compromise the decentralized nature of the network. Right. In addition to that, users vote to select witnesses. Those witnesses are the ones who ultimately the transaction, and those votes are weighed according to the stake, because that is how we discussed what happens in the case of proof of stake. So similarly, it is delegated proof of stake. So that is what happens. The more you stake, the longer you stake, your vote has a higher value. But in this case, if just by staking you cannot validate your note, so you have to, someone has to vote for you, right? And for you to be witness, right? And so there are a set number of witnesses that are always chosen. And apart from that, there's always a different category of people who are essentially just delegates who are given the task of keeping up the network, that the protocol level changes, suggestions, maintenance, everything else. Examples are Lisk, EOS, and Steam. I don't remember the numbers, but all of these systems have a set number of witnesses that can be chosen. I think EOS has either 21, some system has 101 witnesses, and that's how it goes. Quickly, we'll take a look at proof of elapsed time, often used in a permissioned blockchain, right? Why? Because permission blockchains are, we did not take a look at types of blockchains, but there are three types: public, private, and permissioned. We took a look at public blockchains since the last 3 days. Bitcoin, Ethereum are all public blockchains. Private blockchains are the ones which are restricted to an entity. The underlying technology is of blockchain, but they're restricted to a centralized entity. And permission blockchains are where certain entities come on board, and then you need permission to get into that blockchain, unlike public blockchain, and all of the data is not out in the open. However, all the participants can see the data, and then that can be controlled as well. Not every participant can see every piece of data, right? For example, State Bank created a blockchain called BankChain, and a lot of banks have come on board. Axis, Yes Bank, Manchester United Bank, banks from across the globe have come on board of Axis of State Bank's bank chain, and that is where permission blockchains are very much in use, because banks can't afford to let out all of that data, right? Let's go quickly because right. Let's go quickly because we have to cover some practicals as well. An example is Hyperledger Sawtooth. Sawtooth, it is not a blockchain, but it's a framework. You use it for setting up blockchains. All right, a very important concept is Byzantine fault tolerance. As I had shown that this diagram, no, not this diagram. All right, okay, I don't have the diagram today. So yeah, so it's not a consensus mechanism, but it has to be mentioned because it is a problem that I am pretty much sure that every one of you are familiar with, especially the faculties, because this has been a problem for ages, right? And people have already tried to come up with a lot of solutions. And Satoshi Nakamoto, in his emails while building Bitcoin, said that proof of work, the mechanism of proof of work, is an answer to Byzantine fault tolerance. This system is going to be Byzantine fault tolerance, right? Tolerant. And what it is that it is going to take a lot of time. So I'll just quickly give you an idea that in this case there is a Byzantine generals problem where there might be 3 different generals, and they are placed across a field. No one can communicate directly, but every general has to communicate that attack has to be done at the same time. They send a messenger, but the other general does not know whether the messenger was interrupted or hacked in between. In that case, the message will change, and both the generals will be attacking at different times. So then he wants to give an acknowledgement. Then again, that's a problem because the acknowledgement might not reach the first general and get hacked in between. This is a never-ending process. This has been proved in a solvable process. You can go online and check it. So based on this, this criteria was done, that how to make sure that a system is Byzantine fault tolerant. Proof of work solves this for blockchains, because proof of work gives out that proof that this was used, and hence all of those discrepancy cannot creep in. But again, this is out of the scope of this course, and please read about BFT. It is an amazing concept, age old but amazing concept. Even systems, every system which depends on a number of sensors depends on external data from a number of sensors are dependent, or have to be Byzantine fault tolerant. A very good mention would be that even SpaceX has in a webinar I saw that SpaceX was considering their systems to be Byzantine fault tolerant, because when this is a very good example, when the Crew Dragon or any spaceship sent by SpaceX, when it reaches the ISS, for example, just few days back they launched the Crew Dragon, 2 astronauts to space, to the International Space Station. When they're reaching the space station, now one is that it is calculating its own location, where it is currently. Also, it is calculating the location from the space, from the ISS, right? So if this is a discrepancy, that is where it faces a problem, that what to do next and how to depend on which sensor to depend on. Because if it does not know its location properly, it cannot dock into the International Space Station. You can imagine what kind of a problem it would be sitting from here, right? So yeah, VFTs are used across the industry. All right, so this is one example that we wanted to do. Another was this, which we wanted to do, building a blockchain to understand hashing. We have less time. Which one do you want me to do first? Can you just write? Do you want me to build a blockchain, or do you want me to talk to the Ethereum public network using a online library? Okay, so are you oh. Okay, build a blockchain, great. Pushpa ma'am, I have unmuted you. Is there something that I need to know? Pushpa ma'am, you wanted me to unmute you. Is there something that I need to know? Ms. Roop Singh, witnesses are incentivized. Yes, the same way as in any case of any blockchain. Of course, otherwise why would they do it? Pushpa ma'am, if you're trying to say something, it's not coming. All right. Thank you, everyone. Let's build a blockchain. Great. Okay, a lot of building a blockchain. Great. So we'll be taking a look at hashing using this by building a blockchain. It is practically not very possible to build an actual blockchain and put it online into the on the internet and make multi-node mining and everything right now within the next 20 minutes. But it should give you an idea of hashing, right? So let me share the screen. Okay, tell me one thing. People wanted to do it together. So how should it happen? Did any of you go through the class dashboard and get the prerequisites in place? I asked you to install asked you to install Python on your systems, use a code editor, and yeah, do these things. Has anyone done that, or should I just yes, done. Abhinandan Gupta, thank you. Was expecting from you. Great, thanks a lot. Oh, amazing. That's a lot. Okay, that's a lot of people who have done that. So let me know if you have problems in catching up, or I'll try to share my screen. Oh, 1 second. Please let me know when you see my code editor. Online Jupyter works, might work. I have not tested. Should work. I can see it. Great. All right. So I wrote this down. I wrote this. Where's my cursor? Hold on. Yeah. So currently my PyCharm okay for Python. Yes, of course, PyCharm is the best out there from IntelliSense, but I'm using Visual Studio Code because I code in Angular and all as well. So for that I can't use this code editor. And can you increase the size? Of course I can. Please let me know if it increases. Not easily visible, font too small. Oh my god, it has become so big that I won't be able to work in it. Yeah, so this is my comfortable for me. Is it comfortable for you as well? Just a couple of yes would be great. All right, great. Thanks a lot, Shival and all. Thank you. Great. Okay, so I wrote this code before the class. We can what we will be doing is that we will be creating blocks and we'll be hashing them. We'll see the hashing process. This is very important for you to understand that how hashing works. Even though I have explained it in the last 3 days now in details, such detail that some of you have given me feedback that I'm explaining the same concept again and again. This will be the 4th time I'm doing that. So if you are understanding this, then that's great, right? All right. So okay, I'm again hiding the chat. If anything is there, please Pushpa ma'am, please, if you're able to access your mic, please do let me know. Yeah. All right. So I wrote this code some time back. What it does, we just created a class here. All it does is that it allows you to create further blocks. Of course, the class block, it has been aptly named. It allows you to create further blocks, right? The very important thing that it takes is the previous hash. And Another important thing that it takes is the transaction list that needs to go into that current block, right? So that is how they are related. This is the core data structure of a block. Now when you study about linked lists, you first, on the very first day, you don't take linked list and put it on a SpaceX module, right? What you do is, or build an operating system out of it, whether when actually linked lists are in such usage in topics like operating systems. What you do is you try to understand how those lists are linked, right? So before building a blockchain, and while building a blockchain, and while studying blockchain, this is the core concept. If you plan to become a blockchain engineer anytime, this is a core concept that you have to understand, right? So I'll just check once. Okay, great, all is clear. So what this class is doing is that it is taking the very important thing of previous hash and the transactions list, the two things that definitely go into a block, right? Apart from this, you can take a lot of things. You can go ahead and you can add the timestamp. You can add the data, the transaction data, which is actual transaction data, that some data, like for example, in this part of data in the Genesis block, we could not see it today. I don't know how to see it, even I don't know that. I'll have to check. Satoshi Nakamoto in the Genesis block had put this data, a text called Chancellor, on the brink of the second bailout for banks. When people searched for it, they found that this was the primary heading on a newspaper, on a very popular newspaper, I think Times or any of those, in UK's newspaper, on that day, on that particular day. This shows live proof that Satoshi actually did not tamper with the blockchain. He did not go back in time and do that. He actually, on that same day, he created this Genesis block. And also people started believing maybe Satoshi could be from UK, because he's referring to an UK newspaper. But this is the data that goes. We won't take it because then we'll have to hash more, and you get the concept, right? So we are taking the basic code we are just putting two variables. We're just putting the data that we get into the function, into the classes, into the objects variables. That's all we are doing in the first two lines. In the third line, what we are doing is that this is the most important line. This is the most important line, and this is what Bitcoin uses. Every other blockchain uses. The blockchain in its core uses just this concept where, so I'm presuming there are no problems. Great. So Bitcoin, any blockchain, when they are putting blocks, anyone is putting blocks into the blockchain, adding the blocks, this is what they follow. They just have the current transactions and the hash of the previous block. They all take it together and hash it and create the hash of the new block. Like someone asked today, that whether that hash given on top was the hash of the current block. It is a hash of the current block, but it has the hash of the previous block, and also the hashes of all the kinds of data that is in that block. Timestamp, every transaction, hash of every transaction. The entire blockchain is based on hash. I can't emphasize enough, right? So this is the statement that is doing the most work, because it is finding the hash. It is joining the transaction hash of the transaction with the previous hash, right? It is joining the transactions to the previous hash, concatenating. Joining means just concatenating. That's what Bitcoin also does, just concatenates all the data. That's it, and then creates a hash. It does not have to perform any mathematical calculation. And then the next important line is this: it is taking that concatenation of the previous hash and the current transaction data, and then creating a hash out of it. These are the two things that happen. Two very important pieces of data get combined, and then the hash is created. And we'll just quickly take a look to clear it. I hope it is visible. I'll just stretch it a bit upwards. Okay, so let's save it. All right, let's quickly create a task, so that if you are following, if you have opened till now, and if you want me to paste this for you, so that you can paste and start, I'm doing that. You can take from the chat. I hope it works for you. That's a very simple program. Okay, someone needs the feedback link. I hope suddenly asking for the feedback link is not bad news for me, but I'll give that. This is the feedback link, sir. Great. So Mr. Rakesh sir, this is the feedback link I've given in the chat, and also to everyone else who said that yes, you have your code editors opened. please try to quickly go through this code, just copy it, and I think you should be good to go. But I'll proceed because we have people joining from other departments and other areas as well, and I should do justice to them as well. So I'll just quickly show them, but not let them get bogged down by all these code editors because they dread these things. I know people not from the computer science industry, they just dread these things, right? So I'll do that. I'll just proceed. So let's proceed. You don't have to see this code. I pasted it in the chat. So now let's create the blocks, right? Now let's create the blocks. This is running on my own computer, so this is not a distributed network. Pretty obvious. But then once you learn this and once you explore more, you can easily create multi-node networks as well. You can use cloud services. You can use blockchain as a service provided by Azure, Microsoft Service, Microsoft Azure, and all. You can use any of these, and you can easily create a multi-node network. All right, let's quickly get started. Let's first import the class that we have done. No, I think it should work this way, but let's see. Let's first save it as Python. Yeah, right. I hope this works. I really hope this works. And let's quickly create the, okay, this will be very quick. Let's quickly create the Genesis block. We know that the Genesis block is the very first block, so if we are creating a blockchain right now, it has to be the Genesis block that comes first, right? So let's use our own class. And why is it not giving me the previous hash? Okay, the first thing and if someone is finding any error with my Python code, please let me know. It's been some time I've done this. And so let's start giving it. So let's check what all it took. The first thing was it took previous hash, and the next thing it took was the collection of the transactions. Now, as we know, Genesis block has nothing, no previous hash. It is the first block. So let's give a sample. This is the line I've used, which Satoshi Nakamoto himself used just as data, because we do not have a previous block, previous hash. So we'll hash this, right? And now we'll create a list of transactions. Instead of one transaction, we'll create a list of transactions, right? One could be SEMA 1 BTC Shamo. Another transaction could be X2 BTC Y. Let's take a third transaction, maybe 3 BTC to YZ, right? Just random transactions. So this is the list of transactions that we have. This is what is going to go into the blockchain. Now let's just do one thing. Let's print the hash of this block before proceeding with any other blocks. If there's a problem and chat is open, please write it down there. We'll use this function that the block class gives us. So we'll use the Genesis block, and we'll use the function block. The name of the function is block underscore hash. Right, I think this should work. If it doesn't, please bear with me. It can any day. Oh, okay. What have I done wrong? Isn't it? This should have worked. I don't know why it's not working. That's how we import, I pretty much believe. Should work, right? Oh, thank God it works. I'm not able to copy it. Okay, that's not for me. So thank God it works. Finally, let's clear out all that mess and let's run it again. This is the hash of the very first Genesis block. It combines this and this. All the three transactions. It's not just one transaction or that. It first combines these three transactions and then this data, and then hashes it, right? The main thing comes now. Once Genesis block is there, what is the next thing? It's the second block. We'll just do the same thing, and now we have the previous hash because we have the Genesis block as the previous block to this. So we'll use the hash of the Genesis block, which was which was this, right? And now we'll use another set of transactions, which could be x to BTC to O, and we'll take another transactions R for BTC to Y. That's it. Now let's print the hash of the second block as well very quickly. Save. It should come up anytime soon. There is some problem, is it? There is some okay, I'm very sorry. The second block hash will be this. Right, so now we have to, we'll quickly do one thing so that everything is clear. We'll just quickly copy and paste it and make it the third block. I hope everything is visible. Please can someone confirm in the chat if the code you are seeing is visible. Till that time I'll just proceed. Yes, thank you. All right. All right, now we have three hashes for three different blocks. Next, what do? The most important thing, we change anything. Instead of 2 BTCs, we transfer 3 Bitcoins. Just take a look. Currently, this is the hash of the third block. And it will be the same to the second block because the data is same, transactions are same. I shouldn't have done that, but we'll play this and yeah, now we have, let me check once. Oh, that's a problem. Very sorry. This will be third block. We play it. All right, we'll run it. And all right, so these are the 3 blocks. Let's go quickly and please show the outputs. Yes, this is the output. These are the outputs. These are the 3 hashes we are printing. Most important concept coming up right now. These are the block hashes, and every block hash, please take a look, every block hash is taking into account the previous block hash, right? Also, this shouldn't be the Genesis block hash, this should be the second block hash. These errors happen day in, day out, hope you understand. So we have the hashes now. Now changing anything, I make it 4 Bitcoins. On the third one, a new set of hashes are generated. This hash, the one we calculated for the third block, is completely different from the one we just calculated for the third block with just 1 Bitcoin's difference. This was 3 Bitcoins transferred. This was 4 Bitcoins transferred. So that is what happens. One change in any of the transaction data is going to change the hash completely. One concept was this: in the block, if you are changing anything, the hash will change entirely. And when any transaction hash changes, and since we are hashing all the transactions, we'll be ultimately changing the Merkle root, which I have explained for 5 times now. The most important concept comes now is that we have these hashes, we don't touch the third block, we don't touch the second block, we change one character on the very first Genesis block. So just consider going back to the block Satoshi created in 2009 and then changing one character on that block, even in this data that he put, and then running it. Just take a look. Just the one character was changed, the first block's hash completely changed, because of which second block's hash completely changed. No similarity, not even a single character in the same position is same, and hence third block's character changed. This is how whenever you change anything, every subsequent block's hash changes completely. And then yesterday I showed you the BBC video. When any change happens, everyone in the network, every other node in the network tallies it, gets to know that why is this person's why is this blockchain, why is this latest block's hash not the same as ours, I mean as what we are expected to have, and how did it change. That means someone went back and did something, so they can easily retrace. It's a public blockchain that, yes, where we're saying this is the beauty of hash, and this is the beauty of underlying technology behind blockchain. You will get to know in a second that something is there. Today you go and change any record in your MongoDB, in your MySQL, no one is going to get to know unless you actually deep dive. And even if you do, no one is going to be really looking at it from the public point of view. But here that happens. Everyone will understand that the blockchain has lost its importance, its value. They'll fork and create a new blockchain and then go with it. You are left with nothing. Why did you even make that change? Why would you even want to do that change into a blockchain which is not going to exist after people detect that you did something? And people are going to detect very easily. The more the number of nodes, the merrier, I've been saying. The more the number of nodes, this thing becomes very useful, right? That's it. If That's it. This is a blockchain. This all you're seeing, this and including this class, this is all. This is a blockchain. You can now, what else we can do with this is that, so you can keep on, since we are doing it live, what you can do is you can easily create a while loop here, and just keep on adding the blocks. Add more data to this. You can easily add more data to this, timestamp, nonce, anything, more data to this, and the hash will be much more problematic and cryptic, right? And then you can use a while loop here. You can use a while loop here, and you can create more and more blocks, and then you can start mining those blocks, and that's how mining occurs in any network. And you can do this in Python, you can do this in JavaScript, Java, Go, any language that you know mostly will be able to do this. Please share YouTube link on email ID. Mr. Harinder Singh, YouTube link will be provided on the class dashboard. That will be provided. Thank you, Sophia. Thanks a lot for providing the Notion dashboard. So we have a short link for that as well. I'll just put it on chat, and please visit this for anything, because that's the best way we can communicate even after this class, right? So we'll quickly, please use this. A quiz will be posted there. You can take it, and so the length of hash is same, then how it keeps reference of so many previous hashes. I'm sorry, Sonali, so this I cannot make a lot of what I should do with this question, because it is not related. The length is not related. In fact, that length is the best part of it, because you always know that you'll always find a 32-bit hash, 32-byte hash, and whenever that happens, you are safe to say that yes, the calculation I've done is right. So yeah, that's how it works. So the length of hash is always the same, but the hash completely changes, right? It doesn't have to keep reference. Why will it have to keep reference? It already has it stored on the blockchain, right? So yeah, yes, the length of hash is always constant. That is the beauty of the system. It's not a negative point, it's a positive point. So that was the blockchain. You can include while loops. You can put this into 3 different servers, and you can run a multi-node network, and then you can use a lot of, you don't even have to do it manually. There are a lot of tools that can help you set up blockchains on multi-node networks, and you can just run it, and you'll be happy to go. I'm telling you, if you're even happy with this example, I wanted to show you that talking to the Ethereum blockchain example, it is much better. It is believe me, it is very better, because this, we are not even connecting to the internet with this. With Ethereum blockchain, you've explored the Ethereum blockchain online on etherscan.io. Here we plan to talk to the Ethereum blockchain from code. This is something you must want to see. Ankur Agarwal, can you quickly cover smart contracts? So can you please write in the chat, people, that do you want a cover of a basic cover? We can't develop smart contracts right now, but do you want a live implementation of Web3 JS library? Talk to the Ethereum blockchain. We calculate its balance from using the internet, using public Ethereum main network, or you want a quick description of smart contract? Please write in the course, because I know those will pick up. Deepak, can we create private or consortium blockchains? Yes, we can do that, because that's yeah, you can create any kind of blockchain, right? And those are easy. So you can just set up. There are lots of tools available. Hyperledger is a consortium blockchain. Hyperledger provides lots of frameworks for building consortium or private blockchains. You can try that. Talk to Ethereum. Quick description would do. All right, Ankur. So a very quick description of smart contracts. Let's do it, because it's one of the best things that have happened since Ethereum has come, right? I'll just give a description of smart contracts. I don't know if I have a slide for that. Please hear me if that is the thing. And just a second. So all right, I'll see that if I have a slide on smart contracts. I don't have a slide on smart contracts today. All right, so I'll quickly explain smart contracts. What happens is that okay, till the time you're listening to smart contracts, before that, a very important information that I wanted to give to you. about certificates, because I see that people might be dropping off very soon. It's 2 hours now. We still have 200 people, which we had since the beginning. But before you drop off, I think this is the most important information for a lot of people who've been looking for this. Certificates are being provided, I think, for the first time, because it's me. I'm doing it for the first time. I think you'll be receiving it for the first time as well. They are being issued directly on the Ethereum blockchain, and since the last 2 days now, you definitely must be having a very good idea what it means to publish anything on the Ethereum blockchain, and how you can publicly, not even you, someone sitting in the US or anywhere, can take a look at what's being issued on the Ethereum blockchain, right? So, and everything is a transaction. Now, with that, we have seen that every transaction on the Ethereum blockchain costs money, right? So that's where we are. So you can understand that this is a different thing that we are trying out. We are incurring cost by doing this. However, the US the partner is an US based online MOOC platform, MOOC marketplace, who are providing this to us free of cost. They are bearing the charges, and every certificate for maybe 600 of you, first day we received 423 participants, and the last 2 days have been lesser, but still above 300 in total. Providing a certificate to at least 700-800 people, they will incur a lot of cost. But what you have to do to actually get these certificates issued is to register on the program, on the same program. This the same program. You can see it's the Faculty Development Program on Blockchain Technology. The same program on their platform. Otherwise, they will not be able to auto generate and issue them the certificates and issue them on the Ethereum blockchain. So I'll try to copy this thing. I'll try to copy this link. Please go and I'm not copying this link. Please visit the class dashboard. Please visit the class dashboard. You'll find the link at the very beginning on the top, and I'm copying this link again. Please use this dashboard link, please. And the first thing that you'll see is this link to the course. Unless you register here, it will be difficult for us to give you the certificate. Then we might have to only give you a general. Which link was not open, Jayashri? Can anyone else check whether the class dashboard, bit.ly class dashboard link which I just gave is opening or not? It's a public Notion board, free of cost for me. So yeah. Amazing, someone has written it down. Sumayama, thank you so much. You have written it down. You couldn't have copied it from a PPT, so you've written it down and you have given it for everyone. Please take the link as well. There's a course link, and also it is available on the dashboard, and certificates will be sent via email. We are unsure because we are also doing it for the first time. It's a big task that we have taken up on our heads as well, to issue 700 certificates on the blockchain. But that is something that the partner ODEM will let us know directly. So we'll have that information very soon, and we have your email IDs. Whoever attended this program, we'll email it to you. We'll email you what the next step could be. I guess you will be getting it directly from the platform. You'll get an email where the hash will be there, or something of the concepts that you've learned over the last 3 days. Something related to that will be there. You'll take it, you'll go to online, and you'll find your certificate. Something like that will happen, right? All right, okay. Ipshita, now what to do? Just sit tight. That's it. That's all you have to do. Just sit tight and wait for the platform for us to finish this program, for the platform to match who have joined, who has actually registered there, and who have actually joined the program. They'll easily be able to match it because it's all happening on Zoom. And then they'll auto issue it to you. You'll get it. If you have any problems, and Ipshita, I remember you are connected to me on WhatsApp, you can reach out to me as well. All right, great. So we were on a very quick description of smart contracts. Smart contracts came into the picture from before starting that. Can you please know that? Can you please let me know that it is already 2 hours plus? And can you please let me know if it's good to go? And can we extend this a bit? At least I get 10 yes, and I think I should go. Right. So someone has written that there is no registration link in the classroom dashboard. How is it possible? Because I just put it myself some time back. I'll just quickly show you. If you're seeing the Notion dashboard, this is the classroom home. Are you seeing the Notion dashboard? Yeah. Are you seeing the Notion dashboard? Then this is the classroom home, and here is where I'll be adding white text. Even after the course finishes, we should be lifelong learners. I believe in that. anything else will come here. Announcement, the very first announcement is this: the certificates will be issued directly on the blockchain and you have to register for the course. The link is there. Ms. Matilda, I think you should be able to see the announcement. That is the first. There's a WhatsApp group here. Please do not spam that group even if you're joining. The recordings are here for day 1 and day 2. Day 3 recording will be uploaded within the next 2 hours. And more details are there. You want to provide me feedback, the link is here. My books links are here, and the YouTube links are also embedded directly here. Prerequisites have been here, which I'll remove, and yeah. So you should get pages not responding. Okay, okay, I'll just keep it open. If you're able to see it, it's good. I'll just explain smart contracts to you. All right, I'll just explain smart contracts to you. Ma'am, can you please confirm if I'm audible? I'll just continue explaining smart contracts.
Yeah.
Smart contracts are a
Yes,
very
yeah,
important.
yes, sir.
Yeah, smart contracts are a very important concept that came since the second generation blockchain. We could not cover generation 2 and generations of blockchain. I just removed them from the PPT this morning. There are 3 generations of blockchain till now. Ethereum and all are from second generation. They came up with the concept of smart contracts, which is very important. Programming on the blockchain. By programming, by being able to program on the blockchain, we open endless boundaries, right? So what happens is that when you are planning to build an application, so we could not cover decentralized applications as well. They are just similar to our general applications that we see, have a good front end. At the back end, they are talking to any blockchain directly, particularly blockchains like Ethereum, Neo, and such, on which you can build a blockchain, a dApp. So what dApps do is they use smart contracts, and they work according to the rules written in these smart contracts. What smart contracts are? They are just plain and simple like regular contracts. Only thing is that they receive an event to happen, they receive a trigger, and then they run. Once a smart contract has been implemented on a blockchain network, that will be there forever. You cannot change it. I mean, that is again the immutability of blockchain systems, right? If you're seeing that there's a smart contract that has been deployed on the Ethereum mainnet, it will always be there. If your application is using a different if your application is using a smart contract, and there's some bug in that smart contract, you can do nothing. What you'll have to do is you'll have to create a new smart contract, deploy it again on the blockchain, and then make your app refer to that new smart contract. But that old smart contract will always be there. That is why it is very important. I tried, it was out of the scope of this course, by the way. In this industry, smart contract auditing and testing of blockchain networks are very in a lot of boom, because people understand how important it is to actually be able to deploy bug-free smart contracts. Just the way while coding a simple block today, I faced 10 different errors. In your daily life, if you're a developer, even if you're a front end or a full stack developer, you change something, you load the Angular server, you again see that, oh no, something is not working, you go back and you change it again, and you do this, you debug, and you do a lot of things, right? In the case of blockchains, you cannot do that. That is why it is, you can test on test networks. So Ethereum also has a lot of test networks like Ropsten and all, but eventually you have to be very sure before deploying to the main Ethereum network, which is called the Ethereum mainnet, right? So that's why smart contract auditing is very important. An example use case that smart contracts are used is that so when in a previous company we were in discussions with a very popular airline in India. What they wanted to do is a very good example. What they wanted to do was that take the entire insurance, travel insurance online in the form of a smart contract. They wanted to put in on the blockchain. What then would happen is that if the flight was delayed by even 5 minutes, or the flight was cancelled, or anything happened, you as a customer would not have to depend on the flight or the airline to give you a refund or to process your insurance claims. It will be automatically done without the airline's interference. And this way they wanted to garner more trust from the customers, because blockchain is again the trust protocol, as we say. That is why people would have trusted that yes, after I buy this insurance, it is on a smart contract, and airlines does not have any control over it. So if anything happens and the smart contract receives a data from any public resource that this flight is delayed by 1 minute, it will immediately run and it will process your transaction. The flight, the airline company cannot stop it. This is one example of smart contracts. You can implement smart contract examples across domains such as Zomato, Amazon.com, anywhere where you might process refunds based on smart contracts. You click that I don't like the product, the smart contract would know and it will refund you the money, something like that, right? With that in mind, do we can at least 10 people write that do we have time to go ahead and cover I wanted to do that practical today of showing you how the Ethereum network works and how we can actually code to talk to the Ethereum network. Can you please write to me? If 10 people at least write to me, I will use it, because it's going to take 10-12 minutes even if I do it in a very good pace. Okay, more people please, otherwise I will be losing you all. Okay, great. Thanks a lot. I have received 10. Pushpa ma'am, I am continuing with the session.
Okay,
It's a Sunday
okay,
evening.
you
I
can
think a lot of
continue.
people are free comparatively, so we can
Okay, you
continue.
can
I
continue.
have something at 5 p.m., so I'll be done before that. And all right, I received yes. Great. Okay, so I'll be transferring the screen again. This was the Notion dashboard. Let me share my code editor again. Before going to my code editor, I'll just take 1 minute just in case people start dropping, which I'm seeing that people are dropping now because it's code we are again discussing. I'll just love to share a couple of things. Um, uh, let's spend 2 minutes. I received a lot of feedback that can we access the training material in the dashboard? Yes, of course, everything is put there. In fact, the entire recordings are put there. So let's take a look at a supply chain use case, right? I received a lot of feedback. I'll take 2 minutes and quickly go through this. I received a lot of feedback that real world use cases should have been shared. So that's why I've prepared this beautiful slide. Please take a look at it, and let's just quickly go through it. These are practical use cases. Will be very quick, and how blockchain can solve them. Supply chain management, one of the big areas where blockchain can be implemented. Certain problems that this sector faces is quality control, costing, supply relationships, unforeseen delays, taking care of all the stakeholders, and quality control. Quality control is okay. I've written quality control twice. I don't know why. So quality control, maybe that is how much it is important. Quality control is what consumers are really very concerned about. So for example, Amazon did this. Amazon did this with, I think, Nestle or some very popular company. I'm not remembering the name. The use of blockchain eradicated a lot of issues, challenges that we just saw here after using the blockchain as a service from Amazon and implementing blockchain in their supply chain network. So what happened was that the supplier, manufacturer, regulator, wholesaler, retailer, and up to the consumer, everything came on blockchain. Consumer, just to check, the consumer does not have to write to the blockchain because that's the end user. And all right, so they everyone joined the blockchain network, and that companies, and starting from the very supplier, that from where is it sourcing the material, where is it grown, where is it sown, and then how is it transferred. Then the supplier comes into the picture, then the manufacturer comes into the picture, that how was it manufactured, when was it manufactured, using what was it manufactured, everything. Then when was it packed, what check did the regulator do, if it's FSSAI, and if it's doing some regular checks, where is that check data. How do we know that a top food company is not colluding with a regulator like FSSAI? How do we know that? Blockchain is key. Logistics was on the blockchain, that how much time it took for that entire transfer to happen. So if you know that it was not in a cold storage and it took 3 days, that's point, right? The retailer on the blockchain while selling it, when it was sold, everything on blockchain. The consumer gets to go on the blockchain, search using either the barcode or using either any of those identifying numbers, and you easily take a look at what and where the things went, and that way you can easily be very, very careful about what you're having, and you can only trust the brands that are using a decentralized technology behind their entire supply chain management. One very good use case, and Amazon is involved in it, so that's why I thought of picking this use case. A lot of you gave feedback that use cases should be there. Login via Google, certificate not link not cannot be seen. Certificate is not generated, Shweta ma'am, if you've listen, because it's going to be generated later. All right, one very quick use case. World, what we are doing is we are doing the same thing on blockchain. We are also targeting the loans, which is loans sector, which is very fraud prone, and by that we have been able to bring that 15 days loans processing down to 2 days, 1 day. And the banks are our customers, because banks used to face a lot of frauds in this. 2014 Citibank faced a huge fraud in the Qingdao scandal in China, and NSCL scam in India was 5600 crores, right? So that's what we have done. We are doing it, and we are the first live implementation on the Maharashtra blockchain state blockchain sandbox, and Maharashtra's blockchain sandbox is the first in the country. So we are the first live implementation in the country on a blockchain sandbox, as a blockchain platform. All right. All right, please give a demo. Miss Madhila, I don't think you need a demo of how to register for certificates, because all you have to do is just visit that ODEM link that I showed, and you can just register and just sit tight. People from our team will anyways get in touch with you for the next step. All right, let's go ahead and let's quickly let's quickly do this. As you said that we are safe to do this, and let's do that. Let's open code. Let me know once you see my screen. I'll quickly try to show. Yeah, please let me know if you can see my screen. Please, someone let me know if you can see my screen.
Yeah, your
Yeah,
screen is
good.
visible.
Great. So, oops. So let's start from scratch, and let's quickly, very quickly, let me show you what I have to do to talk to the Ethereum blockchain. We'll see how much we can do, right? And so we use a library called Web3.js. It's a JavaScript library. We use it to talk to the Ethereum blockchain, right? It's a library that has all the methods that we need to talk to the Ethereum blockchain, or figure out any detail regarding any particular Ethereum address, right? So what we do is we just quickly start with importing the library. I'll just save it so that I get all the controls. eth2.py. Oops, I have to do it. This is a JavaScript file. Now we are using JavaScript. We used Python to create a blockchain, but now since Web3.js is a JavaScript library and we are writing this JavaScript, so we'll be doing that. So we'll quickly do this. So I just told you there's a JavaScript library called Web3. So we have to import that JavaScript library. I should have had this code copied. I'm sorry, but I'll quickly write it. No worries. And so this is where we please give demo. PPTs and all will be available in the dashboard. So if you're concerned about that, it will be available. How to write a name for the registration? I am not understanding. Please, can you please post some screenshot anywhere in the file here, so that I can know that what problem you're facing with the certificate registration, because when I did it personally, I faced no issues, and a lot of people have around 150 people have already registered for Dr. Shoaib Ahmed. You'll find the WhatsApp link there on the dashboard. You can WhatsApp me directly if you are facing such a problem. You can just share the screenshot, right? And all right. So okay, great. So let's move in. Okay. So we just imported the Web3.js library. Now let's go ahead and invoke that library. So we just created this. Because we imported this Web3 library into this variable, so we'll take it and we'll just, okay sir, we'll share in WhatsApp. Yeah, thank you so much. Right, now we'll use typical very specific functions from this very library to talk to the blockchain. First of all, we'll have to connect to the blockchain, right? So we'll be using a method called providers, and first we have to, because we are doing it online via the port 80 HTTP 8080, and so we have to talk to the HTTP protocol, right? So for that we have a function called HTTP provider. We can easily use it, and yeah, 1 second. Yes, we have a feedback link for the session. Ma'am, can you please also give the feedback link? So this is a feedback link for the session. All right, great. So, and here is where we use the tool called Infura, right? I showed you in the presentation that we use a tool called Infura. So we have to quickly go online. I don't know if you're able to see my Chrome screen, but it's fine because I'm going to. Okay, let me show just here. Let me show the screen because without that you won't be able to understand. Are you able to see Infura? Can please someone clarify if you're able to see Infura?
Yeah. Yes, visible.
All right, great, great. So once you go to Infura, you get started, you create your own account. I've done that part. You create your first test, which is where I should be finding here. Yeah. So this is a project that I've created. I'll quickly take this project very quickly. If you're planning to leave, please stay there. Even if you're not coding with me, this would really be beautiful because you are writing code and you're talking to the Ethereum blockchain, and we'll again go on the Ethereum blockchain and check that as well. Please stay put. 5 7 minutes, right? So we go to this project and we take this endpoint because this is an Ethereum this is an API we are using. So we take the endpoint. This endpoint at the end has my specific project ID. So you'll have to build yours and you'll have to take yours, or you can do that, and we'll paste it here. Okay, so now I'll have to get back. That's all what was with the Infura. So infura.io, right? Infura.io, you can use that free service for to some limits. You can use that, and um, yeah. Are you able to see the code again? Yeah, can you please confirm someone? Yeah. I'll just proceed. Great. I'll just proceed. So, all right. So we have it here, and um, all right. Now we'll be calling. Now since we have that connection to the Ethereum mainnet, and also we have other methods with 1 second, and we have other methods with the provider with the Web3 console, right? So we can access further. Yeah, we can access further methods, and we'll use the ETH method, and we'll use the get balance method. I don't know why it didn't come up automatically. Now this is a method that it provides. What we will use is there a problem? Great. So now what we'll use is that we'll use an Ethereum ID, an Ethereum address here, right? Let's remember this part. We'll come back. We'll go online and we'll pick up a live Ethereum address, right? And that is the essence of this live coding. Otherwise, what's the use, right? So what we'll do is now this part, this get balance function gives you a callback function. So you just have to handle it. I'll give you this code, or you can find it online anywhere, which just gives you an error as well as a request back, response back actually, and then you can just take care. Oops. You can just take care of the error quickly. Just give me 1 minute so that I can do that. This is customary, and else now we are going to do the main thing. Now we are going to log now we are going to print the actual Ethereum balance. To do that, we again use a method. For that is how to download certificate. Okay, we'll answer certificate questions later, right? So now we use another method, which is again the same library, Web3, right? Now previously we used this providers because we wanted to use an HTTP provider. Now we want a utility function, so we use something called utils. In that, now whichever when this thing will get the Ethereum, when this thing will get the Ethereum balance, it will be in Wei, right? Wei is a particular division, decimal point division of the Ether unit, just like dollars and cents and pennies, similar to that, but up till 8, I guess, up till 8 decimal points. So what we'll use is we'll use a particular method called oops, we'll use a particular method called Wei. Just stay with me, I'll be done very soon, and here we will print out the balance. I don't know what's happening. Yeah, great. I think this should work. If it does not, then we all are in bad luck. So we'll now go to let me share my screen again, and we'll take a live Ethereum address. And I'm happy to see that 10 people have dropped. But if you're dropping, just stay 2 5 7 minutes more, and we should be able to close very soon. All right. Let's go to one of the Ethereum blocks and just pick out one transaction. Where is the transaction? Why don't I have transactions here? Why is this not coming? Block transactions. Let's pick up another block. Let's pick up another block. Yeah, great. So now we have this. I believe no, this is the hash. Or let me go inside and let's pick up a. Let's find an actual transaction. Right. So this is from. This is to. We can pick this, copy it, and just put it here. Let me see whether it runs or not. Let me know if okay, you're not able to see the screen, is it? Oh, kindly switch screen. Okay, yeah. I'm sorry. I'm very sorry. All right, so thankfully it ran. And let me know if you're able to see the screen now. I'll just clear it so that you can start seeing
Yes.
fresh. Great. So all right. So what I did was, which I think you missed, is that I copied this. I had kept this blank. If you remember, I had kept this blank. I just copied this from any public blockchain. Just took one of the recent blocks. I copied the. This is just like copying your Axis Bank account number and then able to find your balance. But that's not how a centralized system works. And here it does not mean that I am invading your privacy, but that's what I'm. But I'm able to take a look at your balance, your everything, because this is just one function we are using, get balance, right? There are so many more functions. You'll get a lot of other information. So what we'll do is just run it. Oops. It just came. Let us hope it comes. Yes. So 247 ETH. 247 ETH is what this particular yeah, so now you have a better representation. You must be having a better representation. I've just written ETH. So 247.86 Ethereum is what this public address has. Now, let me confirm. Even I don't know how much actually this public. This is a totally new address that we took. So I'm again changing to my blockchain explorer. Let me know if you are able to see it. Ma'am, can you please let me know if you're able to see it? Can someone let me know if you're able to see it? Yes, great. So this was the transaction. I guess I copied. Yes, 0294. Yes, this is the one I copied just now. You can see I'm visiting this. Let's hope. Otherwise, this would this entire live show would be a flop. Would be very flop. And what I so what did we get? All right. So yeah. So this is showing this as Ethereum 252 as the final balance. Now and we got 247. This is very close, but this had to be the same number. This could be because even I'm seeing it for the first time. This could be because this was one of the very latest blocks that we picked. Some transactions might not have confirmed yet. This could be one of the reasons, but this is what you see here. What you see here on the public blockchain network is what should come in your terminal as well once you use these library to get the balance. So if this does not match, or if you see that it's coming, and if you're taking an old address and if you're seeing this discrepancy, or if you're taking a new address and that discrepancy is coming, it's showing here 252 Ethereum, and for you it's showing 52 Ethereum. That is a serious issue, because no one will be transferring 200 Ethereum, and out of that 80% will not be confirmed. That should not happen, right? So all right, so I think that's it. So that's what we tried doing from here. And so let's see. Yeah, so that's more or less it. If for anything else, if you are so Ankur, can you please rerun the code? Yes, of course I can rerun the code. It might again say 247 Ethereum, because these as you saw that this is not VisaNet. It might take a considerable amount of time to get confirmed. We might have to wait for the next 10 minutes, but I can but you can I believe you can try this at your end using infura.io by talking to the main Ethereum net, and if it does not match, just let me know. If it does not, then it might mean that we are doing something wrong, right? And when we do this in our everyday business, it always works because these libraries are very robust. One more thing I wanted to show you is that if you're able to see my Infura panel, then okay, I'll just paste the code. I'll share the code, but it's a very simple code. I'll still share the code. So if you can see the infura.io, this is where you can change any network. The main net is the Ethereum main network you are seeing. You can easily change it. Your API endpoints will change. Ropsten is a test network. It's a very popular test network. You can get Ropsten testing Ethereum from anywhere on the internet. Just search for that, and you'll get a faucet which will give you some Ethereum in your wallet. We could not cover that. Rinkeby is a very important, very popular test network. Your endpoints change, then you'll just copy it and you'll use it in the code. If you want the code, I am copying and pasting it here for now. I'll paste it. I'll paste it in the dashboard again as well. This is the code you can use. I don't think you should use it because this has the project ID for my project. So if many of you are using it, it will count against my requests, and Infura is not free, so I'll have to close it anyways. So that's where we are. We just used a Web3 library, an online library, to talk to the public Ethereum blockchain. And I think when I started, and when Web3 back then was a bit different. The functions have changed. So if you are going online to check some videos, make sure that your videos are very recent, because Web3 has changed some methods, and very simple methods like get balance will not run if you're using a video from the past, but using Ethereum Web3 version from the present time. So that will become a problem, and you'll be really confused. So that is somewhere we are now. And yeah, so when I ran this for the first time, I felt such an amount of happiness, because I was doing and I was seeing there. It was online there for everyone to see, just as we saw. And here we could see, I could run my code and see. I could change the address and again see. So this is like, this is one of the best. Just a second. Yeah. All right, so I think this should we are done now, because mostly we are done. And all right, okay, so any other questions I might take? I have one slide to how the FTP certificates will be generated and stored in blockchain. So very simple. Everything on the Ethereum or any blockchain is a transaction. So what they will be doing is they will be storing the data. The PDF will be given to you on email. The PDF, the certificate, actually how it looks, it will be given to you on the email, possibly on the email or drive or anywhere. But the actual hash, the actual implementation will be on the blockchain. So your certificate, which none of your certificates till now I can be very assured of have, it's a very rare chance that out of these 200 people, anyone would be having a certificate issued on the blockchain. But if you have, and if you don't have, what your certificate will have is a transaction hash mentioned, the transaction hash that we have been seeing everywhere, right? In all our description everywhere. So okay, 1 second. So yeah, so that is what you'll see, and that is what you can share with anyone you want, right? And 1 second. Yeah, so and that would be publicly verifiable, and you can put that certificate on your LinkedIn, on your CV, and you can also mention the hash and just write there, and anyone would know when they're seeing the hash. Or you can directly search the hash on the Ethereum network and copy that entire scan URL. It's the world is your oyster. You can do anything you want with your new shiny certificate on the blockchain. That's how it should work. And yeah, I think it's done. Right, so I'll just see that if there's anything in the presentation remaining. And okay, someone has said that please share the code, please. Ankur has specifically shared that, can you please rerun the code? Let me do one thing. Let me change the address, right? Let me to verify. Let me change the address of this this thing, and let me see that if we get a different number or not, right? All right, so let me see if I'm sharing. So I just found a new address on the Blockchain Explorer. If you're able to see it, I'll just copy it. So this is an address I found. Yeah, so I've copied it. Let me copy it on my code, in my code. And okay, again you won't be able to see my code. Just a second. Let's clear it. New share, and let me know if you see my code. This is where I've pasted. You can see I've pasted this address that I just copied from a new address from the same transaction pool. It was a contract address. I guess it is a contract address, and let's check. Okay, I've pasted it. Let's check eth2.js. I hope you're able to see my screen. Let's see what comes. It should come somewhere around 1239. Oh, it's 12238. Great. So now you can see that this is 12238 ETH here, right? Let me share the screen again quickly. If you're there, just stay put. This is from where let me know if you're seeing it. This is from where I copied this address. It is 12239. Now it shows that these transactions that you're seeing, these transactions are unconfirmed transactions. They will add and they will make the number same. And of course, if we are seeing 12239 and 12238, of course it's not a fault of the blockchain or the network or even the code, because then it would not be a number even anywhere close, right? I hope, Ankur, you are happy with that confirmation. Like we call it in blockchain, you need so many confirmations. You need at least 6, 7, 8 confirmations, so that you know that the number you are getting, the 2 bitcoins your friend has transferred to you, have actually come to you. Because it might happen that in between something happened, uncle blocks formed or something happened, and you do not get that that transfer, right? So let me know in the group chat, Ankur, especially if you are happy, please paste the code in WhatsApp. We will be losing it in chat if the session ends, right? Very true. What I'll do is I'll write it. If you join the WhatsApp group, please don't spam. Let me just send stuff to it. Ankur is happy. Thank you so much. Ankur means a lot. And Ankur happens to be one of my past colleagues from Policy Bazaar. Thank you, Ankur. And I'll paste it on WhatsApp. You'll get it. Let's quickly 1 minute go back to the presentation and not cover any topics. Just see that if we've missed out anything, any announcements. Supply chain we've covered. Bitcoin anecdote, I told you, May 22, 2010. May 22 we celebrate as the Bitcoin Pizza Day. Why? Back in 2010, someone paid 10,000 Bitcoins for 2 Papa John's large pizzas. That is $41 at that time. Currently, that is $80 million. That means within 10 years, we can safely say that Laszlo that night had pizzas worth $80 million. This is outstanding. That's why we celebrate it as a Bitcoin Pizza Day, if people celebrate it, right? And these are very good concepts, and I at least have 10 more hours of content to share with you. I wanted to pack it all in, but if I went fast, then it created a problem covering a lot of theory and practical. A lot of problems were there. But when I take these lectures professionally, I do it for 3 days constantly, 2 days constantly, and that's 12 hours. We just have spent 6 hours, or today 7 hours. Thank you, you gave an extra hour to me. We have spent, that's all we have spent together. And blockchain is not that small, but it's a revolutionary technology. 2020, please get into this, especially in a time when COVID is creating such a lot of problem. This will be your support. You will be able to stand out very well. 0.25% of Indian IT engineers are ones who have blockchain IT skills. It's the competition here is unlike any as we can compare with any other sector in India, like the IITs, the IIMs, or anything. Like, everything is so competitive in India, but in blockchain, 1 week it will take you to get out ahead of that 0.25%. If you're planning to become a blockchain engineer, now is the time. And since a lot of people still don't have offices resumed, your best time. I mean, these 2.5 months you should have given, and you would have become I don't know what, you would have become a great engineer as well. Let's go ahead and quickly see what we left. This was the all right, this is my last slide. Of course, I can do this. Please, you can take a look at my book, Secure Chains, published by BPB Publications. That's the largest in Asia, and you must have definitely, if you're computer science, you must have read books from BPB. Yashwant Kanetkar is a famous name. Let Us C, Let Us C++, Let Us Java by Yashwant Kanetkar are all from BPB. And so this is a very good book, I believe. I've been able to write with Srinivas Mahankali and Gokul Alex. Srinivas is India's principal blockchain consultant for the government of India, and Gokul Alex is an ex-PwC associate director. And a very important thing I wanted to do before we leave, I wanted to announce my new book, which is the third book, which I wanted to use this stage to announce it. I'm coming up with a new book called Hello World Now for Blockchain. The name, the developers would understand definitely that Hello World is the very first program we do in any kind of language we try, right? It's a very famous thing now. Now I searched a lot, and in fact, when I was starting up, I didn't have a lot of resources to do coding, to learn coding, blockchain coding from. So I am building out a book which will have from basic concepts till end, and clearly illustrative steps of how to build a blockchain, write smart contracts, build a decentralized application, edit smart contracts, audit smart contracts, test smart contracts, and do all of those things on local computers, Mac, Linux, Windows, and cloud services like Amazon blockchain as a service, Azure blockchain as a service typically. And we are and already in discussions with a lot of at least 5 international publishers at this moment. So one of them will definitely pick this up, I hope. Please stay tuned for this. And I really wanted to do this launch announcement at this stage. No one knows about it yet, so please stay tuned for it. That's it. The road ahead. We have concluded a brilliant FDP with a brilliant audience from across a lot of countries, and I'm so happy to have this, so happy to share all of the knowledge that I could in such a short amount of time. That I received negative feedback that I'm going too fast, I'm not doing practicals, but it's not possible every time. And but thank you for bearing with me. Please, the class dashboard is the place where I can reach out to you, because that is one public area where I am putting out resources every single day, most probably recordings, any articles, any concepts, any new tutorials. I'll put it there under proper headings, and everything will be there. And there's a WhatsApp group, you can join it, and please do not spam it, and no one spams it. And all educational materials are shared there, and anyone who spams is kicked out. So that's it. Thanks a lot. Thank you for joining me today. Any feedback? This is the most important part after the entire session. This is the most important part. Dr. Pushpa ma'am, please, you can take over till the time I'm just giving this feedback link. Thank you everyone. Please give this feedback to me. It's an anonymous 10 seconds feedback that you can give without your name and anything, without email address, anything.
So finally, this is the time to end of this FDP session. So thank you, Abhishek, for sharing your precious knowledge and making this FDP interesting and meaningful. In day 1, you leveraged us with basic concept of blockchain. Day 2 was related to practical aspect of public Ethereum block and consensus mechanism. And day 3 was really wonderful. This is really a wonderful session. Actually, you leveraged us
practical,
practical,
right?
Practical yes. Aspect of blockchain. It's really valuable for us. How to create a blockchain, about idea about the smart contract. So finally, I, Dr. Pushpa, on behalf of Delhi Technical Campus, Greater Noida, would like to thank you all for attending the day 3 session of FDP on blockchain technology. Thank you very much for making this event successful. And I hope you all enjoyed the today's session. Thank you so much. Thank you, Abhishek.
Thanks a lot. Thank you very much, ma'am. Thank you, DTC, and thank you, ODEM, for doing this for the first time. If anyone
actually, for the certificate, we will provide your certificate on a public Ethereum blockchain very soon, just after verifying the attendance list of participants. So till yes. Then, kindly wait. Okay.
Yes. So please, please stay put. So please stay tuned that the ODEM team will let me know How are they issuing the certificate? See, this is people are not very easy and very
Yeah, yeah,
like accustomed to blockchain as a concept,
yes,
right?
yes, yes.
But we are doing this for the first time. We are providing you certificates on the Ethereum blockchain. Even it's first time for us, so we have to figure out that how does it actually go to you. But it is going to be on the blockchain. That's my promise. You will have a transaction hash for the first time
Definitely,
ever
definitely.
on your certificate forever, lifetime, till the time you'll be alive, and even beyond that. So and please give me feedback. This is my feedback link. Please give me feedback. Please join the dashboard. Please join the WhatsApp group if you want to stay connected after this session. And thank you so much for being a wonderful audience. Great. Thank you so much. Thanks a lot.
Thank you. Thank you, Abhishek. Thank you.